ये तो है गूगल का, गूगल उसका यूट्यूब
ये
का।
दोनों दोनों चल रहे हैं। यूट्यूब वाला लिंक से खोलेगा बस। हाँ, उसमें आ रहा है। हाँ, मेरा फोटो नहीं आ रहा है। मैंने करा है। मेरी आवाज आ रही है नहीं, चेक कर लो, है ना। शेयर कर रहा हूँ यूट्यूब वाला आगे। आप लोग है ना, जो आएगा उसको होस्ट बनाओगे और उसे परमिशन मतलब स्लाइड पे शेयर करोगे। तो होस्ट बना देगा तो खुद ही शेयर करेगा। Am I audible, madam?
Yes, sir.
Am I audible? मेरी आवाज मेरी आवाज आ रही है? हेलो। अच्छा सर। अच्छा हाँ, मैं ऑडिबल हूँ सर।
Good morning, submit chair, sir.
Good morning, sir.
Good morning, Nagdi sir. Love कुछ this side.
Morning, sir.
Morning, good morning.
Good morning, one and all. With the blessing of His Holiness Jagat Guru Shri Shri Shivratri Deshi Kendra Mahaswami Ji, I am Megha Jain. On behalf of JSS University Noida, extend a very warm welcome to our respected Principal Sir Dr. B. Manoj, Summit Chair Dr. R.S. Jagdish, all HODs and faculty members, and last but not least, dear participant. Today, we all have gathered for one-day summit titled Data Intelligence Nexus 2026, from analytics to autonomous decision making. This summit aimed to bring together academicians, industry experts, policymakers, and researchers to explore the evolving landscape of data intelligence, artificial intelligence, and government framework. So, without any delay, I request HOD IT to brief about the summit. Over to you, sir.
Thank you, ma'am. Honorable Vice Chancellor, sir, respected Principal, sir, respected Chief Guest, distinguished speakers, esteemed faculty members, industry leaders, and dear students. A very warm welcome to all of you. With the divine blessings of His Holiness Jagat Guru Shri Shivratri Deshikendra Mahaswami Ji, President of JSS Mahavidyapitha, and under the visionary leadership of our Honorable Vice Chancellor, sir, Shri H.R. Mahadev Swami, sir, along with the constant guidance and support of our respected Principal, Dr. B. Manoj Kumar, sir, our respected Registrar, Dr. T.G. Mamta, ma'am, our respected Controller of Examination, Dr. S.S. Surut, sir, Summit Chair Dr. R.S. Jagdish sir, and our respective Finance Officer, Mr. N.S. Manoj Kumar. It is a matter of great pride and privilege for me, on behalf of Department of Information Technology, JSS University Noida, to welcome you to a one-day summit on data intelligence NEXUS 2026, from analytics to autonomous decision making. The objective of this summit is not only to discuss technology, but to explore how to intelligent system can create meaningful impact, foster innovation, and contribute to sustainable and responsible growth. Through this platform, we aim to strengthen collaboration among academia, industry, and policymakers, enabling the exchange of ideas, research, best practices, and future opportunities. Today, we are honored to host eminent academician, industry leaders, and policy experts who have made significant contribution in the field of artificial intelligence, data intelligence, and smart governance and innovation ecosystem. Their insights will undoubtedly inspire all participants and provide valuable perspective on the future of intelligent enterprises and digital governance. I encourage all the participants, especially our students and young researchers, to actively engage in the technical sessions, case studies, fireside discussions, and panel discussion planned throughout the day. The true value of summit lies not only in listening to expert, but also in asking questions, sharing ideas, and building meaningful professional networks. I would like to express my sincere gratitude to our distinguished speakers, guests, organizing committee members, faculty coordinators, industry partners, and student volunteers whose dedication and hard work have made this event possible. I am confident that Data Intelligence NEXUS 2026 will serve as a catalyst for new ideas, collaboration, research initiative, and innovation that will contribute to India's growing data economy and intelligent future. With these words, once again, welcome you all and wish you a highly enriching, insightful, and productive summit. Thank you. Over to you, ma'am.
Thank you, sir, for your kind words. Now I invite our principal, Dr. B. Manoj Kumar, sir, to say few words. Principal, sir.
Yeah, thank you. Thank you, madam. With the blessings of His Holiness Jagadguru Shri Shivratri Deshikendra Mahaswamiji, I warmly welcome the eminent speakers, Dean Student Welfare of JSS ETN as well as JSS University, Head of the Department, faculty members, and students to the one-day summit on Data Intelligence Nexus 2026. Good morning to all. I congratulate the Department of Information Technology for organizing this timely summit on the theme Bridging Data, AI, and Policy for Intelligent Enterprises and Smart Governance. This is the theme. And this theme, we all know that artificial intelligence and data intelligence are reshaping our industries as well as our society. And such platforms are essential to promote innovation, collaboration, and responsible technological advancement from students. So I encourage all the students to participate, actively engage in today's expert talks and panel discussion, and make the most of this opportunity to learn, network, and contribute to building a smarter and more sustainable future. I take this opportunity to thank our industry and academic partners for joining hands with the JSS University and contributing to the success of this summit. Of course, your collaboration, expertise, and continued support are invaluable in strengthening academia industry partnership and creating meaningful opportunities for innovation, research, and student development. And I request all the faculty members of the department actively participate in this event Anyhow, the revision of syllabus for JSS University is going on, and make use of this summit for revision also. And my sincere appreciation to the head of the Department of IT, the organizing team, the faculty members of the department, and students for their dedicated efforts in organizing this summit. I wish the summit a grand success. Thank you.
Thank you, sir, for your valuable thoughts. Now I invite Summit Chair. Now I would request Summit Chair, Dr. R.S. Jagdish, to say a few words. Over to you, sir.
Thank you, madam. Good morning to everyone. With the blessings of His Holiness and respected Vice Chancellor and Acting Vice Chancellor Dr. B. Manoj Kumar and Dean Academic, respected faculty members, industry expert, researchers, and students and participants. It is my privilege to welcome you all to the summit on Data Intelligence Nexus 2026 from analytics to autonomous decision making. This summit has been thoughtfully designed to explore the rapidly evolving landscape of data intelligence, where the traditional analytics is advancing towards intelligent autonomous systems capable of making real-time decisions. As artificial intelligence, machine learning, generative AI, and advanced analytics to continue to transform every sector from healthcare and manufacturing to finance, governance, and smart cities, it has become imperative for academic and industry to work together in shaping responsible data-driven innovation. I sincerely congratulate the Department of IT, HOD, and faculty members for organizing and also conceptualizing this timely and highly relevant summit. Such initiatives provide an excellent platform for knowledge sharing, interdisciplinary collaboration, and meaningful interaction between academic researchers, industry leaders, and aspiring professionals. They also reflect our JSS University's commitment to nurturing innovation, research excellence, and industry-ready graduates. I express my heartfelt gratitude to our Honorable Vice Chancellor, Dr. H.R. Mahadeswamy, sir, our Acting Vice Chancellor, Dr. B. Manoj Kumar, Registrar, and management of JSS Mahavidyapita for their constant encouragement and visionary leadership in promoting academic excellence and industry engagement. My sincere appreciation also goes to our distinguished speakers, whose expertise and insights will undoubtedly enrich today's deliberations. I encourage all participants, especially our students, to actively engage in technical sessions, ask thought-provoking questions, and make the most of this opportunity to learn from experts at the forefront of data intelligence and AI. I am confident that today's discussion will inspire new ideas, foster collaborations, and contribute to building next generation of intelligent and ethical decision-making systems. With these words, I wish the summit great success and thank each one of you for your enthusiastic participation. Thank you and wish you all the best. Thank you very much.
Thank you, sir, for your kind words. Now I request all the dignitaries, participants, and faculty members to switch on your videos for group photograph.
Ma'am, we can take photograph in continuation where program is going on.
Okay, ma'am. Okay, sir. Thank you, sir. Thank you all. Now I request Dr. Prachi Chabra to introduce our expert of the day.
Thank you, Megha ma'am. Good morning, everyone. It's my great pleasure to welcome our esteemed speaker for today's AI Summit. Please join me in giving the warm welcome to our speaker, Mr. Surendran. He is currently working at Atlan, the AI context leading organization. He began his professional journey as a lecturer at JSS itself. With over a decade of experience in data analytics and AI, he worked extensively at the intersection of data-driven innovation and AI. He is passionate about applying emerging technologies to solve real-world problems. Please join me in giving a warm welcome to our speaker today. Due to some technical glitch, he is joining in few minutes. Surendran sir, are you here?
Yes, yes. Can you hear me?
Yes, I'm here. I'm here, able to hear you. Kindly share your screen. Yes.
Can you see me?
Yes, sir.
Perfect.
Okay, sir.
Let's get started. Yeah.
Sure, sir. So you can share your screen.
Oh, I can get started, is what you're saying? Okay. Give me 1 minute. I'll start.
No issues.
1 minute. I'm just setting everything up. There we go. Can you see my screen?
Yes, sir. So your screen is
Perfect.
visible.
Okay, perfect. Thank you. There will be a small lag in my internet, meaning like from the time I speak, it will be like 2 or 3 seconds before you will hear it. And that is normal. Just giving a heads up before we start. And with that, let us get started. How's everyone doing today? Who all do we have here? I believe lots of students and teachers, I guess. Perfect. All right, let's get started. Hi, everyone. Good morning. My name is Surendran. I work for a company called Atlan, and I'll talk a little bit more about that in a few minutes. But before I go there, can you all hear me very clearly, or do I need to adjust my microphone or something to make sure we all hear me properly? Prachi ma'am,
Yes,
Sukendra
sir.
sir,
Yes, sir. We
you
are
can all hear
able
me
to
clear.
hear you, sir.
Perfect. Okay. So I have a presentation that I'm going to walk through, and maybe we can, if time permits or if it is possible, then we can do a little bit of Q&A or something like that at the end. And with that, let us get started. So my name is Surendran, like I was saying. Some of you might know me from the past. I was a faculty in the department some 20 years or so, or 18 years ago. We'll talk about that also a little bit. And I'm very, very excited to be back here and talking to you all. I know the topic Sukendra sir had shared with me was, something about data intelligence, AI, and so on and so forth. Of course, I'm going to talk about that, but I thought it might be interesting to take a step back and like look at like what is happening and what's happening in the world and stuff. So the reason I chose this, or the reason I thought this might be interesting, is like I work for a company that is the product we build and the customers we work with is like predominantly about how to make AI more useful for companies and so on and so forth. So with that, let's get into it. So like I said, my name is Surendran. I work for a company called Atlan. And so Atlan is a context layer platform, as we call it. So as all of you would know, that AI or large language models are like very, very powerful. You can do a lot of things with it. But to make it really useful, you need to teach it or give it more context, as we call it. And now context means that as we say, AI is like super powerful, but it needs to understand you and your business so that it is able to do things better. So that's what we do. We also are like a very AI native company. We'll come to that in terms of what AI native means. But in one phrase, AI native simply means like, yes, AI can, generative AI and large language models can make us more efficient. But can it also make us more, can it help us do our work better and dream bigger and imagine and so on and so forth. So yeah, I was here before in 2008 into 2009. And, I just wanted to quickly think of do a quick comparison, right? Like what changed in the world between these things, right? Android was Android was coming up. It was not, this big. We're like still early days of our Facebook and so on and so forth. Cutting to now, right? So many people are on the internet, and ChatGPT and Claude and all of these things have become super mainstream and so on and so forth. Yeah. So it's a very different world, at least from the perspective of how I see, because it's not like we were not teaching AI or like talking about AI back in the past. Like, we still had papers around it. And, I have very interesting memories from the time of like, people writing papers and like, going deep into concepts and stuff. But like, we certainly live in a very different world. So yeah, I mean, like a quick like trip down the lane, like, we've been talking about AI since like the 50s. And, what makes the AI that is possible today is that, we finally have reached the place where, and this is sort of relevant for us in the room, right? Like both as teachers and students, that what has really changed is software has changed, meaning we are able to write better algorithms and so on and so forth, meaning like breakthroughs in maths and physics and so on and so forth are contributing to it. We have, immense amount of computing power now that we didn't have in the past. And then like, for about 30 years of internet has given us a lot of data that we can work with that kind of like makes the story come together. I mean, like what really happened in the last 10 years is a culmination of what sort of like started 50 years ago or like more than that in the 1950s. Now, the recent developments are in the last 15 years, we have like better algorithms, more compute and a lot of data to work with. And, it's, that's kind of like the background to this development. And I put this in slide in just to give a sense of what is possible with like technology today, right? And like, again, some of us might go into research and like dig into it and stuff. It was in 2012 we really understood like what is possible with like compute if you do it properly, which is 2 GPUs was able to like, you should go and read AlexNet basic. It's like, the computer started recognizing what a cat is and things like that. But essentially like 2 GPUs were able to solve a problem that like 50 years of theory could not. And like, that's sort of like 2012 was sort of this beginning of AI as we know it today. And I put this as a reminder to understand how rapidly this technology is developing, right? Like if you think of it, how many years does technology take to reach 100 million users? Your good old telephone took 75 years, mobile phones took 16 years, but ChatGPT took like 2 months. And almost like 1 in 5 people or 1 in 6 people today use ChatGPT across the world. Just to give a sense on like how fast this is growing and like the size of the opportunity in front of us and stuff. Yeah. Again, like how fast this technology itself has developed, right? In 2010, remember, like, if you showed, it's not like people weren't researching. There's a lot of research going on and so on and so forth. But, in 2010, we were not able to say the difference between a cat and a dog. Like an algorithm couldn't do that, right? But by 2015, we had reached the place where AI could like very deeply recognize things in a way a normal human cannot. But by the time we got to 2023, it was able to clear legal exams. In 2025, AI was able to win the gold in the International Math Olympiad. And today we are at a place where like, AI is like able to work like 16 hours, 18 hours on a problem statement to solve like really hard problems and so on and so forth. Again, something to keep in mind for us, right? Like both as educators and students on like the kind of technology that is available to us as we look forward to solving different and better problems in the society and so on and so forth. Meanwhile, while I'm going through this, if you have questions, please keep dropping them in the chat. We can take it up later as well. This is sort of like continuation of what we were talking about earlier. Like software is one of the places where AI has made a huge difference, right? Like in the sense that it can write code and fix bugs in a way that it was not possible before. It is able to reason and do things and so on and so forth. The other interesting thing to remember, right? Like while AI is probably a very critical thing to keep in mind, any technology disruption or adoption is like driven by how expensive it is for us to pick up and use or like adapt or like incorporate it into our day to day. And I'm guessing some of us would remember that phone calls used to cost 16 rupees a minute on when mobile phones were first introduced in India to now, for the same cost, you get essentially unlimited access to phone and internet. Right? Like AI is not any different. What used to cost $20 in November of 2022, in 2 years it got to a place where it like literally costs nothing. It's like too cheap to meter as we call it. Now, why is this important? This is important to remember because the number of problems we can solve or like the way we build things is fundamentally changed, and I'll come to that in a minute. Fundamentally changed, and the cost is like incredibly low for the amount of benefits that we get out of it, and it is only our imagination is the limit to what we can do with it in that sense. But taking a step back, right? Why is this new or better, right? Like, why is AI or Gen AI? Why do we what is the hype? Why is it important, and so on and so forth? I sort of like personally consider this to be the most exciting technological revolution that we are going to see in our lifetime, or probably in the history of humanity so far. And that's for a couple of reasons, right? Like this is not the first time we invented a technology or we created a technology that fundamentally reorganizes how society operates, how individuals operate, and so on and so forth. The difference this time is that, if you can go all the way back to fire, right? Like fire, wheel, electricity, steam, all of these things are like general purpose technologies that fundamentally rewired how societies work. The major difference is that all these technologies, there are about 25 or so technologies, depending on how you count, that foundationally rewired how society works and human beings work. Most of the technologies so far were kind of like giving us superpowers or augmenting us to do more things. But we did not have a technology that was able to create. And what I mean by create is that, you can go to ChatGPT and ask it to write text, make an image, build a deck, or, ChatGPT or Claude, or, make an image, generate some music, make a video, and so on and so forth, right? Like that is new. This was never possible in the history of like technology, right? Like electricity was good. Electricity enabled us to, create computers, and computers enabled us to create software, and so on and so forth. But we never had a technology that could create human-like or human-level output, and which is kind of like, it can write code, it can write English, it can translate, it can design images, it can make websites, it can, generate music, it can, generate videos and movies, and so on and so forth, right? Like, which is sort of why it is very exciting, and the possibilities it enables is endless, right? Like I said, electricity helped us move things from place A to place B really well, but like AI helps us to can think as well. Here's an important stat around this, right? So in the latest Google I/O, where the CEO of Google or the leadership of Google introduces said something very interesting. They said like 75% of new code written at Google today is written by AI, right? I mean, of course, engineers using AI in that sense. So now contrast it, right? Like 2 years ago, roughly 2 years ago, 18 months ago, only 25% of the new code generated at Google was written by AI. Now, nearly 3/4 of the code is written by AI. And it is profound if you think of it, right? Like the speed at which we can develop things, the kind of problems that we can solve for, and so on and so forth. It's a very, very, very new world and a very fascinating world to live in that sense. Yeah. One second. Yeah. So this is super interesting, right? Like, so when we think about like what will be engineers of the future doing, what will companies of the future be doing, and so on and so forth. Now, I want us to take a moment here to recognize how critical or important it is. Like a company of the size of Google, where like 100,000 people work, one of the more technologically advanced or one of the most AI native companies in the world is like publicly they are at a place where they're like 75% of the code is written by AI, and they've been accepted by engineers, and they are able to solve problems in a way that they could never. Now think of um, what what this slide will read like 18 months from now on, like the kind of products they can build and the kind of problems they can solve and stuff. But is it just about software, right? Like not really. If Google has another subsidiary called DeepMind where they work on a bunch of projects, and AlphaFold is one of those things. So there's some very interesting research behind this, which we can, or data behind this that we can go. But I wanted to throw this here because protein folding is a really hard problem. It will take like many years for one person to do this well, and it is very critical for like drug discovery, healthcare, and like understanding diseases, understanding if how to discover new drugs or how to build new drugs that can solve diseases and so on. So think like Alzheimer's and dementia and cancer and so on and so forth. But one AlphaFold project, which is it's an AI tool in a sense, was able to fold 200 million proteins and enable new kinds of drug discovery and so on and so forth. And best of it is that it is available for free. Like across the world, people use the AlphaFold database to do what they are doing. And it was so profound that the Nobel Prize for Chemistry was given to Demis Hassabis, who is the head of DeepMind, CEO of DeepMind, the AI frontier AI lab at Google. But interestingly enough, the award was given for chemistry because that's what AI enabled to solve. So AI is not just computers; it is like very much in the real world, right? And some other ideas on what it means in the physical world, right? Like one of the things I was most fascinated by the last time I was in California was I took a ride in Waymo, which is a fully there's driverless cars, as you know, right? Like there's no driver, and I took it from place A to place B, about 20 minutes of ride. What was more interesting was like every week now, about 500,000 driverless taxi rides happen in the US, right? Across 10 different cities. And it was like mind blowing to sit inside a car and without a driver, and it takes you from I was probably going from a meeting to a railway station to take a train to go somewhere. Now, why is this interesting? Again, like taking a step back, right? It's easy to say, oh, 500,000 rides a year and like huge numbers and stuff. But it's important here to take a step back and like, again, as teachers and students and educators and students, what matters is that the 500,000 rides that we see today is a culmination of about 20 years of research, right? Like, the Stanford driverless research lab started in 2024 or thereabouts, and there have been lots of students who went through the lab, people working on masters and PhDs and so on and so forth. There were so many different aspects of it. That is like physics and chemistry and mechanics and electronics and chips and law and training and software and so on and so forth. It took 20 years to get it to a place where it is going to have an immense impact in the world, right? Like the shiny numbers look like shiny numbers, but it's critical to recognize that it takes like years of work and like very exciting work. And probably what is relevant for the future is that, I really hope that what took us 20 years to solve, we might be able to solve it in 5 years in the future. And have like technology breakthroughs at a velocity that we were not able to do before or was not possible before. Here's another from medicine, right? So there's a study they did to understand, what is the role of AI in medicine. As you read it, right, 300 more very, very complex cases, where if a physician was working alone without the help of technology, they were able to solve about or diagnose about 20% of it correct. But if they're working with AI, they were able to solve 85% of it. Now, again, the point of the last few slides or the ideas is that we fundamentally interact with AI today for a number of things via our computer, but writing code or using it to write a paper or do some research and stuff is one part of it. But it has a immense and a profound impact on the world across physics and chemistry and cars and medicine and so on and so forth. So there's so much more important problem to solve, difficult and critical problems to solve that we can solve in the future working with the AI. Again, from our own examples from our own our own country, right? Closer to home, where you can pick up a phone and send a voice note and get an impact, get a response back on some very critical questions what are the policies that I can use and so on and so forth. And now again, language is not a barrier, technology is not a barrier, and so on and so forth. Again, impact AI has in the policy or public policy and welfare schemes domain. And now, where do we stand? Yeah, India, is we all are a part of it. India is number one in AI skill penetration, more than 3 times more than what the rest of the world does. We are, per ChatGPT, we are the second biggest country in terms of number of users and also number one in terms of student users and stuff. Again, just to give a sense on what it looks like to for all of us, what it means to use AI and how prevalent or how in depth the usage is. Now I wanted to okay, let me pause here for a minute. Does anyone have questions or thoughts or stuff before we go to the next set of things? I guess no. All right, let's go. So I wanted to also touch upon a very important aspect on what it means to build the software, right? I'm guessing some of us will go in, there are a lot of engineers who go and build the software. Some of us are going to start our own companies and stuff, and some of us go and work in other places where a bunch of places where software is software basically, as Mark Anderson, one of the founders of the creator of the browser, or I'm forgetting the name, the browser from the past, said that software eats the world, which is true. Every aspect of how we Netscape browser, so that's what the software is very integral to how we work, right? Everything, our phone, our computers, when we pay a bill, when we swipe a card, and so on and so forth. Every aspect of our life is governed by software. But there's something very, very interesting that is happening, which has profound impact on how we build software or what software is, which is for about 50 years or as long as we have been building software, this is how software works, right? Like software is a set of workflows. There is a human who's sitting in front of it and who understands, makes a decision, and like, takes the action, and then the software records it. Think of it as like when you withdraw money from an ATM, right? Like you go, you look at it, it shows you some information, but you still have to close the loop, right? Like where you have to make the decision: is this information correct? Did I put my PIN accurately? And then you press a button and then it dispenses the cash and you're done with it. Same with when you make a payment with your credit card, or you're logging into your email, or making a purchase on Amazon or Flipkart, or using your phone, and so on and so forth. But I mean, the long story short is software is a filing cabinet, or like a system of record, and a human was sitting in front of it. The intelligence was human, and then the record of the decision was made, right? Like that's what the software that we know. But the software of the future is completely something else, right? Or like software right now, which is there is an agent in the middle, or meaning like AI is able to use the software, and AI, like it's not just the human that is using a software to accomplish a task. Now AI is in the middle that can make the decision and complete the task. And I'll come to that in a minute, right? Like now, what does this mean for us, right? Like what does this mean again for for us as individuals, for us as in the roles that we do as teachers, as students, as like employees, and as entrepreneurs, and so on and so forth, is like the mindset, or like our mental model needs to change, which is software is not just a tool that you operate. Software is a colleague that you work with right now, or like AI makes it possible, right? Like you work with a tool, or like it's not a tool that you operate. It is a person, or like a system that you collaborate with to solve. I have a very interesting example for this, like at the end, which is this is literally how it works, right? Like there is software and intelligence, and there is agents in the middle that is like doing the work. If you have time, I might show you some examples of like what this means. All right, yeah. Moving on. Here is an example, right? Like I wanted to leave you all with, right? I'm sure all of us are aware of Linux, right? And one of the most consequential technologies that ever existed. It powers all the software and so on and so forth. Linux was added to GitHub in 2011 or about 2012 or thereabouts. And one of the most impactful pieces of software that exists, has a lot of people working on it. All the companies rely on it for powering all the mission critical infrastructure, from banks to power stations, to how governments operate, to how Google manages our emails, to how Apple builds phones, to banking, life care, or like healthcare and lifestyle, and pharma and retail, and all the industries depend on Linux, and none of us are new to it. But it took Linux about 15 years to reach 220,000 stars on GitHub. Stars on GitHub is a simple way where we calculate the popularity of a particular project. OpenClaw, on the other hand, is an open source agent software. I'm guessing some of us might be using it. OpenClaw became more popular than Linux in 100 days than Linux became popular in 15 years. Like that's how interesting the world is right now, or how fast AI agents are being adopted by people, and so on and so forth, right? Like the graph is like, one of the most important graphs, or like one of the most interesting graphs that I can think of in that sense, to show how rapidly proliferation of agents is taking place in that sense. And like, again, if you have time, I can show you an example of how I use OpenClaw, right? So what does this mean for us, right? And going a little bit, right? What does AI enable us to do? And I wanted to share a personal example of this as well, right? I work at a company, of course, right? Like I work in marketing, I have a full-time job and a family and so on and so forth. And I always wanted to write code that helped other people as well, right? Like though I've never been a professional developer myself, I could, I understand computer science. I was teaching computer science, but I never wrote code professionally. I never, worked as an engineer in a company to write software. And then something changed, right? Like these are like 8 examples of like what things that I was able to build in the last year or so, or probably year and a half, which is like an Android app that is able to talk to my car. Now I can build games. I have an agent that is able to monitor the health of a plant. I run for exercise. I get like detailed analytics about how uh, am I progressing, and right, like I am able to. I built an app that like tells me like if I take a photo of what is in my fridge, it tells me what is a good meal that I can make, and like and so on and so forth. Now, what is interesting, it is not just I was able to build these things and I use. Some of these tools are used by like tens of thousands of people across the internet. Now, building is possible, right? Like in the limited time that I have, like, over the weekends and so on and so forth, I could build all of these things because AI makes all of these things possible. Now, the reason I added this, or like, the idea that I wanted to communicate on this is like every single person here could build things that they want to. Now, building is not limited only to can I build software? Building is to solve a real world problem and, uh, you know, um, to better maintain your car, to play games, to take care of your garden, to take care of your own health, to be able to focus on work more, to figure out how to eat healthy, to to do a whole lot of other things. Yeah, this is possible only because of AI. Now, the way it works is I have an idea, I leave a note or a command to one of my agents, and the agents do the research and do whatever they're supposed to do, and then come back with an answer or a product. I'll show you some of these things as well in a minute. Yeah. 1 second. Yeah. All of this is possible today. Like now, as you know, we measure intelligence in tokens today. And this is just a thing on like how much. I use 3 different tools, and like just this year alone, the tools that I use combined have generated 7 billion tokens. Now, the point is not like the number is not the point. 7 billion tokens is it's just a number and so on and so forth. It's just that it is not something, AI is not something personally I use simply for efficiency. It is how I do research. It is how I think about strategy. I use it to build apps, debug software, plan campaigns, analyze the impact of our work, understand what pain points our customers face and how to solve it, and what it takes to solve, and so on and so forth, right? Like it's just it like as one of the themes that we had for this talk was like, what is the nature of data intelligence? This is for me a great example on what is the nature of data intelligence. It allows me to understand my own self better, our team better, our company better, our customers better, because intelligence is not just limited to rows and columns in a database. Intelligence is now data intelligence, or like being able to derive business intelligence and data intelligence and so on and so forth, is possible by integrating with large volumes of data, like data in a database, code in GitHub, tickets and conversations that we have with our customers in different places and stuff. You bring all of those things together in one place in a way that I'm able to deeply reason into it on like, okay, why is this a problem? Is this a problem because it is difficult to use, or is there a bug? How many other times the same problem has happened with the same customer or a different customer? So if it is a recurring pattern, can we automatically go and fix it? And if we can fix it, can we measure the impact? And impact really is the problem that they were facing. Are we able to solve the problem? And so on and so forth. all of this is possible today. And of course, it is measured in tokens. And all of this is the more important thing to probably take away from here is all of this is possible for one person to do. What used to take teams of people to do is like, now possible to do with one person, right? So this is what the idea is, right? Like it didn't just make me faster. It has given me abilities that I was not actually qualified for in the past, right? Like it makes ambition. It's not just efficiency, it is ambition. Or in other words, like we can teach everyone and we can, as personally, we can aspire, and as teachers, we can nudge everyone to be not just 10 times more ambitious, but like probably 100 times more ambitious, right? Like you see a problem, you can go build a tool that will fix the problem and, actually take it to the real world and see the impact and like, learn things better and so on and so forth. So yeah, I mean, what does then it mean for the future, right? Like, we should be able to build better technology. We should be able to build better science. We should be able to build better companies. Like, for example, problems that were too hard and required hundreds of engineers now can be done by a team of 5. In fact, some of the fastest growing companies have like less than 50 people working on those companies, and they've built like new companies, like categories that never existed before, like, problems that were too hard to solve before, and so on and so forth. Yeah. All of this is, technically possible today because AI makes all of these things, or intelligence today makes it possible, right? Which leaves us a more important question, right? Like as if many questions can be answered easily by AI, or like, if finding answers is relatively easy, what do we teach, or what do we talk about? How do we enable the next generation to be better, or how do we prepare the next generation for what is going to be true and what is that they can aspire for or imagine or have ambition for? It is very simple. It is almost possible, or it is possible almost 100% of the times to find answers to very difficult questions if you know how to use AI properly. But the most critical skill today is knowing how to ask the questions in that sense, right? And that is probably the biggest gift that we can, or like the biggest skill that we can enable the next generation with, which is there is a powerful technology that you can use, but you can use it really well if you know how to ask the right question. Now, asking the right questions is not like a simple fact of like, am I phrasing the questions properly, but actually asking the right questions. Like, can I deconstruct the problem into its components and like, properly understand each component so that I can get a very first principles and, core understanding of the problem so that then I can go solve it one step at a time, right? Now, an interesting question to ask of the students is like, we are in July of 2026. You're all going to probably graduate. At least the final year students have like a few more months to go, or like a couple of semesters to go before you will graduate. An interesting question you can all ask yourselves is like, what will you ship? Like, is it a product you want to build or an idea you want to test, and so on and so forth. The only thing that matters is, do you have a good idea? Can you ask the right questions, work with the technology, and a laptop with ChatGPT is all you need, or Claude is all you need to go solve that problem. Now, there is a very interesting course that is happening in Stanford as we speak, CS 153, I guess, Frontier Systems as it's called. The headline of the course itself is that today it is possible for one person to solve a problem that earlier took an entire company to solve. And their goal is, by the end of the course, all the participants in the course, their project work is that they build that company by themselves to solve a very hard problem in the world that earlier took an entire company to solve. Or in other words, one individual with the right tools and right mental models can solve a problem that earlier took an entire company to solve. So the question for all of us today is that, can we become that? Can we go build something in the next couple of semesters before we graduate? Right? And why is this important? You're all the first or probably the second generation of students who have access to, like, the reason you will not be able to solve something, like, as human beings, we always lack the knowledge and the skill to do something, right? Like, and that is what experience teaches us. Like, you become very skilled, and over time you accumulate a lot of knowledge, and that's how you become good at something and enables you to solve problems and stuff. But the recent generations of students are the ones who are not limited by their access to intelligence, right? Like, what took me 15 years to learn, it doesn't take you 15 years to learn anymore. It might take you a week to learn in that sense. So access to intelligence is not the problem. The question is limited only by imagination is what the problem you can solve is only limited by your own imagination in that sense, right? Now, probably here is the most interesting thing, right? This deck, the one that I've been using to walk everyone through for the last, 40 minutes, I didn't write one word in this slide, in this presentation. This entire presentation was built by AI, right? It did research. There are 7 parallel agents. It did the research. I was asking the questions. It did the research. It did the fact checking. It looked at like the primary sources and like put the deck together. The first version of the deck was the colors were a little off. So I went and gave it feedback and so on and so forth. But mind you, not one word in this deck I wrote, not one line of code for this deck I wrote. In essence, if I can show you how I built this deck, I built this deck on my Claude Code terminal by chatting with AI like this. This is what I was doing. This is how the deck was built. If you see my screen, right? Like, I started with saying, I have to give a presentation, educators and students, and I'm Sukendra sir is my friend, and so on and so forth. And after that, I have just been giving feedback. I did not build the deck. And just to show you a possibility of what AI really makes it possible today, if you and it runs on the most recent model that was shipped 3 years ago, and so on and so forth. Yeah. And yeah, so here we are. It was not, it's, AI is not just a paper that we studied, which is true. When I was in this room the last time in 2028 at JSS, AI was a paper that we were teaching. It was a research paradigm. And, people went into long research programs to research on AI and build things. And it is not that anymore. It is here. It is in our daily lives. It enables us to do a whole lot of things across a whole lot of domains, right? In cars and medicine and healthcare and law and manufacturing and marketing and sales and so on and so forth. And what is more interesting is that I think the world has scratched only probably less than 5% of what large language models and generative AI today makes it possible. The rest of the 95% is yet to be realized. And I hope people in this room are the ones who are going to help realize the true potential of it and solve problems that are never solved before. I'll pause there. And that's the end of things I have to show you. And if you all are interested, then I can show you another example of how agents help.
This is Sukend Singh.
Yeah.
I want to ask a question.
Yeah.
Don't you think these AI tools are creating a divide that professional version or paid version are are more capabilities, and free versions are less capable. Don't you think these are creating divides among people?
That is always true, right? Like your feature phone is less capable than your smartphone in that sense. So that kind of like product level differentiation will exist always. But like here is what I know: the smallest, and you shouldn't call it the cheapest, the free open source models that are available out there are more than capable of solving a lot of problems, and it is up to us to use it properly in that sense, right? And what I mean by that is, um, um, you know, you don't necessarily have to be limited by what a ChatGPT most advanced ChatGPT version enables you to do. If you can set up the open source version of ChatGPT or DeepSeek or Gemma, or like all companies have like great open source models out there, they are capable of doing immense amount of help, and we should use now. To answer your core question more directly, yes, paid versions, because you pay for compute and you have to pay for like software and compute and whatever. So paid versions will always be paid versions. They will always be one step ahead of the free versions. But the free versions are still will enable us to do things that we could only do, like we could never do in the past.
Claude is uh, offering so much limited things to us in free version. So
Yeah.
when do you think they will add more compute for India?
No, I mean like every token generated requires compute, right? Like the real problem with scaling AI today is compute, meaning we need to build more data centers, and we need to build more data centers, and more data centers require more power, and that requires us to like build our own power generation capabilities and so on and so forth. So over the next few years, that is what will likely happen. Like we need more power, electricity, which will then lead to more data centers, and data centers need more material. Like you need processors and RAM and CPUs and cables and fiber optics and internet and so on and so forth. So the true potential of AI will only be realized over time when we are building out more compute capacity, which enables us to do more. Unfortunately, today the world is limited by compute capacity. And there is no easy way out for it. Did that answer your question? It's okay. Pratima, you can take over.
Yes, thank you. Thank
Yeah.
you, sir. Yes.
Does anyone have questions?
Sir,
Or
yes, sir.
yeah.
There is one question from one of our students.
Yeah. But how could I gain skills which make me to use these tools for betterment? Yogesh, the answer is very, very simple. You just have to start using it. Like the only way to do this is using it. Like say the way I think about this is, it is a tool, right? It is tool, it is software, it is a piece of technology. AI is not some new thing that has happened. It is the same as internet. It is the same as smartphones. It's the same as laptops. It's a piece of technology that enables us to do things, right? Now, any technology fundamentally allows us to do three things, right? It enables me to do something faster, meaning it allows me to become efficient in what I am doing. It allows me to, or it enables me to improve the quality of what I'm, so I can produce better output. So I can become more efficient. What used to take me a week to do, now I can do in an hour. It enables me to produce better output. I hate making presentations. I'm not a fan of making decks. right? Like now I made a decent deck. I didn't make it. AI allowed me to make a decent deck today, right? Like, so it's allowing me to do better output. The more critical thing is it allows me to solve harder problems, right? I could never build an Android app in my life. I could never build a bot in my life, and so on and so forth. So the question for all of us is like, can I become efficient in what I'm doing? Can I produce better quality output in what I'm doing, or can I do better work, or can I learn newer things? What is faster, better, harder, or efficient, quality, and innovation is different for different people. So Yogesh, you should ask yourself on what are the skills I need to learn. Do you want to be a front-end engineer, a back-end engineer? You want to be a researcher? You want to start your own company? You want to, I don't know, go work on renewable energy, whatever. You need to define that, and then AI is the tool that will allow you to get there faster. That will allow you to learn better. That will allow you to solve problems, right? Like hypothetical example, if you are very interested in renewable energy, then the question you can ask yourself is like, before the year ends, can I go and build a real world project in renewable energy that I can use? Maybe you'll end up starting your own company, or maybe you'll use that as a project that you can show to potential employers, or maybe submit it to one of the government schemes and get it funded. The possibilities are endless. Only your ambition and imagination are the limiting factors.
Okay, sir. Thank you. We have one more student.
Yeah,
our panel.
please.
Sir, what mistakes do beginners make when learning AI?
Not using it enough. That's the only mistake. The more you use it, the more you'll get better. Right? Like not using it enough is the most, or the funniest beginner's mistake I've seen. There is no such thing as like mistakes. If you don't understand it, you can ask it to teach yourself.
Okay, sir.
Yeah.
Okay, sir. Thank you, sir, for
Cool.
sharing your valuable knowledge and insight. Your session was highly informative, inspiring, and providing us with a deeper understanding of the topic. We sincerely appreciate your time and guidance. Thank you once again for joining us.
No problem. Thank you very much. It was very nice chatting with you all again. Thanks.
Thank you, sir. Okay. Good morning, sir.
हाँ, good morning, ma'am. Is it audible, madam?
Yes, sir. Yes, sir.
हाँ, हाँ.
It's my
Thank you.
great pleasure to welcome our next distinguished speaker, Dr. Vijay Bhaskar Semwa. We are honored to have you, sir, with us today. Your expertise and contribution to the field are truly inspiring, and we are eager to learn from your valuable insight. On the behalf of the Department of Information Technology, JSS University, Noida, I extend a warm welcome and invite you to address the gathering. Thank you, sir, for joining us. Dr.
Thank you.
Vijay Bhaskar Semwar is an assistant professor in the Department of Computer Science and Engineering at Maulana Azad National Institute of Technology, Bhopal. Prior to joining Manet Bhopal, he held assistant professor position at NIT Rourkela, IIIT Dharwad, and NIT Jamshedpur. With over 7 years of teaching and research experience, Dr. Semwal earned his PhD in robotics and AI from IIIT Allahabad, Prayagraj in 2017. His research interest embraces a variety of fields, including human-robot interaction, IoT, variable and sensor-based health monitoring systems, artificial intelligence, machine learning algorithms, and theoretical computer sciences. He published more than 50 research papers in Scopus and SCI index journals and international conferences. In addition to his research, he has organized and conducted more than 10 short-term training programs and workshops, as well as 3 international conferences. In 2019, he received the Early Career Research Award grant of 25 lakhs from DST SERB Government of India. He is the senior member of several professional organizations. Dr. Samwal has successfully completed 3 research projects totaling 5 lakhs funded by the Science and Engineering Research Board, the Technical Education Quality Improvement Program by Uttarakhand Technical University, and the seed grant by Manet Bhopal. He is currently supervising 2 external funded projects worth over 1 crore, sponsored by the Higher Education Funding Agencies and Minister of Education, as well as Madhya Pradesh Council of Science and Technology. So, we welcome you.
Ji, ma'am. Thank you. So can I start now?
Yes, sir. Your
Yeah.
slides are visible.
I hope it is perfectly audible as well as my screen is visible.
Yes, sir.
Okay. So good morning to all the participants. First, I would like to thank Department of Information Technology, JSS Noida, for giving me opportunity to speak on such a relevant topic, data analytics for small governments, and one-day summit over data intelligence Nexus 2026, which is very important. So thank you, Prachi madam. Especially, I would like to thanks also Sukendra Singh sir for inviting me to over these platforms, and it is very well platforms over which we can connect with the young minds. So once again, thanks departments, and good morning to all the participants. So now what we'll do, we'll dive into deep, and I basically divide next 45 minutes. I will discuss about 3 concepts. First, we understand how scientific discovery to we reach in the current AI area. In between, we'll understand data analytics, and we'll see the some aspects or case study of small governments, public policies, like you have seen Aadhaar card and others, biometric security and other sort of things for small governments with the help of AI, big data, cloud, and data analytics, obviously. So it's a big journey. So I'm not going in very technical. I'm just giving you overview on some of the case study. And then last, I will conclude before concluding, I will discuss about democratize AI, how AI will become accessible, usable for each person of India, how we can give the penetration of AI to every sector of India. Okay. So then only the democratization of AI, and then we'll see the what is the impact of AI, not only cognitive aspects, what environmental effects. That's why we now landed over the carbon aware AI. Okay. So with this, I will start. So once again, I'm Dr. Vijay Bhaskar, working in department. So there is QR code by which you can access my website as well as my LinkedIn profile, and in future you can connect also. Okay. So first, let us understand how it's evolved, because obviously we need to be the core of fundamental of all discoveries, whether it is technology or anything, whether quantum data, and somewhere we believe in the traditional science, scientific discovery, the way the brain is explored. You see that modern computation evolved from the neurological science, brains, neurons, because the modern AI is connectionist AI. So it is nothing but the sequence of neurons which used to activate, fire, which used to get tear, and we can't repair the neurons due to the biological limit. So then later on we believe over instrument, and we know that now we have very powerful instruments. And now it is not physical like glass and bars. We have AI algorithm and chip-based silicons, and edge AI supports microcontroller. So historically, scientifically, we make the big jump, while the observational tools having certain limitations. Then we keep searching over the technology and solutions so that we can get the new solutions, as we know that the key of any discovery is that the curiosity is okay. So आवश्यकता ही आविष्कार की जननी है. So like this, we found some limitation over observational tools. We greatly involve the science and technology, and now we are in era where we are working without any hardware and things. Okay, so you see that initially we had physical observations century ago. Of science relies entirely on human senses. Now we have sensor technology by which we collect the data, and then these data we need to process. We need to make noise free and pre-processing. Then this data will store in big data tools. Okay, and then the big data tool will process through these analytics so that it become meaningful things. So earlier we believing over the human sense, and we have physical observations manually works. Okay. Later on, we have greatly transformed in industry 2.2 or 3 by electronics equipments, or electricity was produced. By this, we started doing significant leaps and increased meaningful beyond light limits. Okay. Then we came in the era of computer around 1980-99, when computer started penetration across the world. Everything was digitally transformed. It was the really changes in which India was never behind. Those in steam engines or electricity, we were too behind from the other countries across the globe. But in case of computer technology, we were well aware. Those initial hesitation was there, but later on we adopted this technology, and you know that the world highest number of engineer in computer science and data analytics we are producing in the world's top class also. The modern science generated data in the form of not bytes, kilobytes, or gigabytes. It is in the petabytes and huge amount of the exabytes. So which is very difficult to store, as well as traditional computer can't store. So second thing, that we require big data or cloud. Okay, so in the form of, because now multimedia data coming in the variety of forms: image, video, text, sensor readings, 1D dimension data, medical fields, image, x-rays image, and all sort of data we need to store. So cloud is required. Big data, because data is coming in the form of volume, variety, viscosity. Within a fraction of a second, each person is producing more than 1 GB of data in the day and consuming also. So huge network blockage also is happening, and we are in the heap of data. Data is the fuel in the future. For data, there will be fight in the futures for countries. Once we have data, you become very intelligent. Okay, so data is the fuel. Unfortunately, India don't have any data centers. We are still living on high companies, Google and others, which maintain data, IBM and other sorts, that do not be in India. But certainly, once we are managing such a big data centers, so obviously environment impact will cooling and other effects, and environment pollution, and then we miss our target of net zero carbon emissions to save our ozone layers. Okay, so that our few kids or other next generation should save. So cloud computing over there, which data will store. Now we are in the era where edge computing device itself becoming powerful, and miniature based devices coming which will have computations and okay. So how AI is helping scientific, before diving into the data analytics, let us see the application. So analyzing massive amount, because data is the fuel. All algorithm will perform based on the data. It is not like traditional algo. You will write the code and then you will get the predicted output. The way you will train the data biasness is also there. Model will become biased. Okay, so it's happening in the biological fields, biotechnology, environment science. Does
Sir?
actually especially smart.
Excuse me, sir.
Yeah, ma'am. Hello.
Sir, your slides are not moving.
Okay. Okay, I will share entire screen. Okay. Once again, entire screen. So now you can see my slide.
So,
Eh?
yes, sir. Yes, sir. Done.
This slide already you have seen. I will discussing about this slide because I started. This is my third slide now. So in between also you can please intimate
Yes, sir.
anytime if I will lose connections. है ना?
Sure, sir. Sure. We take-
है ना?
Okay.
So this was just I told that ki physical observation to me scientific or technological where we had sensor variety of sensors through which we capture data, whether it's camera sensors, temperature sensor, pressure, healthcare sensors, or variety of sensors. And you are extracting data in the form of multimedia, videos, audios, text. Data become the fuels, and then we have to challenge over the petabyte of data we produce. So where we will store traditional computing were not sufficient, so we went for cloud. Once we are going cloud in the form of big data, then we need to be structured data. Structured data you can get through big data and other technology. Then to visualize, as human can only interpret some statistical things, some graph and something, so we need to have data analytics and become very big tools. Okay, the way AI is moving, data analytics is becoming very good, or data science, especially you see that data science which is related to data, even IoT application you are getting. Okay, so AI is penetrating every domains, biotechnology, environments, drug discovery, smart decision making, policy makings. Okay, smart governments, which I was supposed to discuss about some of the things. So let us connect with the century old concept. Raman studies how well, C.V. Raman, who got the Nobel Prize 1929 around, how light interact with the matters. Today, AI studies how data interact with the patterns, or whatever knowledge we can discover through the data. So the data is the raw materials, knowledge we are extracting, that is important, which we call pattern. So if you see that data science, it is not single domains, not it is related to computer. It is interdisciplinary natures of the scientific methods, process and system to extract knowledge. Ultimate objective to extract knowledge from the data. So data is fuel, but knowledge discovery is there. It is interdisciplinary. It include your computer science, big data, machine learning, so which basically require linear algebra, mathematics, science. Basic science will remain same, statistics and domain expertise. If you are from agriculture fields, agriculture domain. If you are from marine science, you have required. If you are from government agencies or fire safety department, you require this kind of. So all domain are connected with these ones. And then we are processing it very formally. We are pre-processed data, we are designing the model, and that become very efficient because you can't simply believe over AI model until it is very trustable. So trustability concept is coming, where you will see later on explainability of the models, how model it. So correct model designing is very important. Otherwise, your predictions or your classification may become. Then you require exploratory data analytics, and various techniques are there. Okay, you heard about Python and R to explore these data. Okay, and ultimate objective to discover or extract knowledge. I will tell ETL technology later, but what is this? So hypothesis derived to know the extent, and maybe you wrong hypothesis can be very dangerous. Okay, so ultimate objective, it is interdisciplinary data science. You are playing over data, and see how industry has adopted data science drastically. You see that year by year from 2011 to next year 2027 prediction, see that the growth is almost 50 times. Okay, and the market volume in the billions US dollar, if you see that this is the market volume. Initially in 2011, 7.6 billion US dollar was industry was doing over data science, but now each and every country or company is working somehow they are using AI and data science. Okay, so huge growth and huge potential over this data science. So how data science workflow? So through real world, as I explained you, through sensor, now we don't have physical, biological sensor, we have physical sensors, which you can have any sort of this one. So we are coming with this one, real data, real words, through sensing, whether it is smart grid, whether it is mobile phone, whether it is your wind plants, whether it is your digital twins or kind of things you are taking. You have huge computation, you have very good communication technology to transfer data from one place to, then you have to process on the fly. The way you receive the data, and suppose you are wearing the smart watch or some wearable device, immediately the data should reach to you in some meaningful form. So that means in background some data analytics is going, and the data should be scalability storage. It is not like we can store only some amount of data, after that it will lose that. We need to continuously store the data. Okay, then processing, especially to visualize, especially to make decision making, scientific discoveries, prediction of things, and growth also. Okay, so just it is not big data. Okay, it is something which we have done over big data to predict the meaningful values. Okay, so it requires especially mathematical or computational or statistical model. Okay, which is we are telling the model, AI models. Okay, then we infer the hypothesis from there, and that hypothesis could be correct or wrong based on the data niches. Now coming over the topic which I have given, smart, or we can say e-governments. That means e-governments over your mobile phone or over internets. E-government means electronic media. Okay, like we see that and public policies which bureaucrats used to make, so that each and everyone should get. It should be inclusive. It should cover every social or society. Even last person sitting in the village should get the reachability of the government initiates of things. That only will be possible through AI, but you will get visualization through data analytics. So you see the power. So government has initiated the democratizing AI. AI should become the weapon, or not weapon. It should become the tool for each citizen of country. You can't deny, any government agency or government department can't deny using of AI. You can take help of AI, but it will become only democratized. First, we need to make equitable. It should not be like rich people will get access and poor will not. Gender biasness, no, any sort of biasness we don't want. So it is to be equitable, everyone should get, and it could be inclusive. Okay, then it should be open access, not proprietary kind of things, heavy cost you need to pay and burdens. It should not be too much technological kind of things you require to very difficult kind of coding you need to write. No, plug and play kind of things. Even person is not from computer science background, electronics, they should adopt this ones, and everything's available over there. And which I was telling, the major pillar is that ethics and transparency. You have seen the wonder of AI, but you have seen what problem created by AI is in the form of deep fake, deep videos. Multiple countries, you have seen social media fight is happening with the fake video and other things. You see that. Okay, so we need to collaborate, academic, industry, and governments. Then only you can get a smart government over. Then you need to make people educate. You need to make AI accessible to everyone. So laptop all can't be, mobile phone mostly Indian are using, but some other kiosk systems and digital things by which you can get financial literacy, you can get digital literacy, you can get other sort of literacy. Okay, so that time you require academic help which can make these modules so that people can understand the learnings. And this one, industry will facilitate fundings, design the hardware and all sort of things, and government will design the policies. So what will be the impact of democratizing AI? Will empower the communities on the fly, on the second you will get the decisions, your problem will solve in the sense, no one will be very, very discriminating kind of things. Okay, then you will have economical growth. Okay, you will have least dependency over physical hardware and things. The transport cost will reduce, emission, environment pollution will reduce. Okay, dependency, bricks and buildings kind of structure will not require you are from sitting at home, you are getting all sort of decisions. So man, then will greatly transform our workforce. Okay, job opportunity will become, a new innovative solution will keep coming, and AI is unbounded, no one can stop. Okay, only thing to adopt AI. But what we are expecting, our own AI solutions, especially if you see AI for healthcare and in improve diagnosis and treatments, save times. Okay, accessible healthcare for to rural areas, multilingual AI. You see that this year budget was translated into different languages. People understood better. Earlier it was only in one English, but now you can translate into your own language, Hindi or Bengali or some other language. You can translate, you can understand Tamil, Telugu, Malayalam, and whatever. So on a fly, the moment the teacher is delivering, it is getting translated to all. And we know that we are natural learner by default. Mother tongue is quite comfortable for us to understand anything. So now coming on role of governments and which sort of policies we can form. So first, the government need to make AI as a public infrastructure. It will become only once it is accessible to every citizen of country. It is not that big data center is there. So nowadays AI algorithm is running over the big or giant data centers which having some teraflop or some kind of computationals. But what is happening? Government of India initiating giving GPU facility on the hourly basis, on the subscription basis, on the minimum cost, maybe 40, 50 rupees, which you spend for your tea, coffee, or samosa and other things. That kind of cost you can bear for 1 hour access getting the AI GPU servers. So this way, the government has to penetrate and take AI to this level and make infrastructure. Okay, so that you require to intact the network connectivity, every sort of thing. Then data governance premise. That means data storage, data transparency should be there, and there should be no leakage of data and no personal data privacy, all sort of. So these kind of government policies like drone policy we are framing, Government of India initiate data policy also, because one day we are expected to 100% shift on the data governments. Maybe your core decisions will based on the your AI, your examination copy which evaluated by AI. So human factor will not there. Those there is multiple drawback with the AI, sole responsibility of AI. Then it is very difficult. But anyway, okay. So we need to be focused about the data governments. How through data we can take. Suppose we are getting pictures from there, the road is blockage or something. We take a smart decision. Government should take a smart decision. Get shifted the traffics, or if any damage in the roads or any blockage of the your drainage and other things, such kind of things. So data governance, so data security, data privacy becoming very important. Leakage of data will lose the trust of people over the governments, okay, or over AI models. Funding for inclusive AI research. And another inclusivity is not there, then it is just dream of AI reaching to everyone. So okay, we need. And third is digital literacy. The people who are not much aware of AI running or least bother about AI algorithm learning, so they must have digital literacy. Okay. So now you see that if government has to maintain the record and the things very important, we have our Aadhaar cards or national identity card, we are preparing one cards. So biometric recognition. Similarly, the way you are storing the data, your iris data, your fingerprint data, your face recognition data, it becoming very crucial to store this data in the form of encrypted forms. Continuously 24 hours you are the surveillance. You know that in China, the policy is that they used to monitor you 24 hours, and they will grant you loan or any government facilities based on your good behavior. Your good behavior index is more than 7.5, like your CGPI, then only you are entitled to get government facilities. If you are not following your ethics, so they are monitoring whole day behavior, and after that they are deciding your score, like we have our civic score on the financial to approve the loan. So they are seeing what transaction I've been, whether I'm paying on timely or not, also. Similarly, your behavior will be also important to get government facilities, government loan, government infrastructures. So that kind of things can be possible through the AI and data analytics. So this is what we call digital transformations. Okay. So identification, match founds. Okay, we can easily identify the unauthorized persons going. So through various biometric, but the challenge that we need to protect this data very carefully. Someone's data can be compromised, become very troublesome in the era of AI due to this defect technology or generative AI technology, which can generate the similar data and patterns. Okay, we can do crowd monitoring by surveillance. We can allow the access to mass people. So manual scrutiny, manual frisking will be done. NEET exam we conducted. So can we have automated in library? You just go and scan through the door. Door will automatically open and you go inside. These are, it is not people are not working or not happening. That data is possible to store. Okay, we can get their age, gender, and emotion, and we can also see if some person is trouble. What is the intention of person? Whether it is in troubles, we need to protect him or some kind of because society is becoming also big challenge. So emotions by seeing facial expression, by seeing behaviors, or sometimes we are panic situation, our behavior is entirely different. So that kind of things we can, and government will have very fast decision on this thing. So it will certainly going to happen. Okay. Digital security, which is very challenging. Okay, now IoT device, IoT security is becoming very challenging. So anytime your data is over the digital space and you are over the heap, the moment you are compromised, maybe you need to keep proving this is our data. You have seen that many times financial loss is happening, many times physical loss, many times wrong information is also those digital evidence. If you compromise, it is very easy to detect whether it is original or compromised data, okay, altered data, okay, audio, video, and text forms. So you can see that some of the things, AI must be safe for society. PM Modi on the deepfake, he emphasized in the G20 meets. So AI scam is happening, government one. Many time what is happening, AI algorithm is wrong. Suppose I prepare budget of 50 lakh for my lab. I need to validate through AI. AI also will generate some labs, but infrastructure AI algorithm will just selling in 10 lakh rupees, you can prepare the data set, which may be beyond reality, and that is not truth also. Okay. So we are just taking your video sequence and altering, like Monday is replaced, you see that how the data is updated. Earlier that this is the speech signals, some of the portion where I was telling Friday, it is changed to Monday, and things will become very troublesome for someone. If it is political person happening, you see that in during 2020 election in Delhi, you have seen multiple instances. You see that Delhi BJP Pramukh Manoj Tiwari was speaking in Haryana, though he can't speak in Haryana very fluent. Such kind of video is fluent and which can appeal the mass. Then it is not true democratic. The people whom I need to do work, I'm alluring by different way, different schemes. The road is damaged, but by AI I can reconstruct this. This is highly unethical things. Highly unethical things which need to be controlled. Okay. So deepfake video falsely claim Lieutenant General Rahul R. Singh admitted loss of the S-400 system during Operation Sindhu. So this kind of news, and this is PTI, Pakistan TV is running these things. Aadhaar versus deepfake, how UIDI keep your identity safe in the age of AI fraud. For especially getting admission once you are PWD condition, UDID, unique disability identification ID, people can change. Rising threat of digital arrest, exploiting deepfake is past concernable, and it is very challenging. Someone can commit suicide by seeing the police and other things. All people are not made like they will face all the trials and things. So fact checking is becoming. You see that during Bihar election, more than 400 fake video was run by the national news channels, and there is agencies who used to control. They need to block these things. They need to send a warning next day. So sometime from other country data we are running. So what will happen in this case? The government will find very difficult to manage. Anytime a chaos is happening, social media is becoming hit rate kind of things. Country is going to divide into small zones. Which technologies try to remove, but technology somehow made the peoples. They are getting very angry also over there, and they are writing comments. Okay. So many times these incidents can, one or two people can get suffer some things. Okay. So we need to be very careful fact checking. So we need to be very democratic while we are using any language. We should not post anything without verification, because so far the data is coming over internet is very unauthorized. Maybe by 2030 the data will come authorized, all data over it. So we can expect that AI algorithm will perform. Privacy become very challenged. Any times to take revenge, people are using this tool to damage someone else's image. Okay. National identity cards systems is there. You have PAN cards and others. So drone-based person attribute recognitions and multiple things we can do. Okay. We have smart ID cards by which we can define. Now moving for another aspect, Indian traffic and information sign processing we can do again through with the help of AI. Easily we can detect the cars, and if someone has committed something in the night, autonomous vehicle sensing. You see that Delhi, Bhopal, Sagar, Riva, and Varanasi, Patna. So first ever day and night time data collected, AI algorithm requires, and This is published by ICER Bhopal. Okay. Let us move towards healthcare application. You see that Google has tools Linina for identification breast cancer tumor, that the metasize to nearby the you can see that the bottom of nodes. Okay, so this sample image is showing that limbs nodes with the multiple artifacts. Okay, the dark zone on the left in the air bubbles, the white sparks. Okay, so this way you can detect the cancer also, breast cancer and others. Like Clue app is there by which you can predict the periods, timely forecast users, menstruation cycles, and reproductive health checkings. So you are getting enough amount of data, and digital infrastructure penetration is getting, so better health qualities you can get, you can mount. But it is only inclusive once it should reach to every section of society. AI helping the drug discovery future before happening any kind of new disease coming in the market by 2028. We are expecting, like COVID was there. So that time, which kind of drugs is suitable to which kind of society or which kind of gene or sequence. So predicting the protein structure like alpha force, you have learned this very famous model in the AI. Design new drug molecule using deep learnings for particular disease, for cancer detection and other cancer curing. Reduce drug discovery time from 10 to 15 years to few years or few days. So corona disease for the drugs were discovered within 2 years, but can we have shorter time with help of AI and other smartness with the previous experience? This is how AI algorithm is used. Some of the case study I kept here. Okay, 3D structure, 2D structure. This is the how AlphaFold's algorithm decided us to find the protein structure. AI is also very much informative in the climate prediction, environment science. You see that multiple floods, landslides, other things we are having. We are very typical kind of hardware like for inputs, radar, satellite, weather station, aviations. Okay, we are collecting data and we are predicting well ahead of times. Okay, so predicting climate change pattern, analyze satellite imagery. We can see that the growth of the water bodies or sinking of water bodies, small ponds and small rivers, or what the effect of urbanization we can also see. Models extreme weather events, optimize renewable energy. AI process petabyte, that I told it is in now petabytes. Okay, AI also help in genomic and the biotechnologies. So analyze massive genomic data, detect disease biomarkers, enable precision medicine, very accurate medicine they are telling which is suitable. It is maybe person to person different. And maybe in future, some medicine will not given to every few persons. First, they will analyze your structures, genome sequence, and then will prescribe you, doctor will prescribe you some sort of medicines. And maybe in front of this one, your genome sequence is stored. The drawback is that your genome sequence can be changed. Okay, and this is again problems due to the fake alteration of genome. AI discover hidden genetic patterns linked to it. Okay, in astrophysics also, so it detects the exoplanets, classify the galaxies, identify the gravitational waves, filter telescope noise. AI helps scientific discovery object individual to manual analysis, which earlier we used to do. So I'm not doing, there is multiple tools of Gemini, and now I will dive over the democratized AI, and then we'll see that the impact and loss of AI. Okay. So AI is fundamentally rewriting the timeline of the biological research, which earlier traditionally we used to do. Okay, various modality of medicals. Through Gemini, we are having 2D, 3D or sequence. We can go for classification, visual question answering to reports. So precision medicine, AI co-pilots, telemedicine, all sort of things. Now, what are the initiative of governments to sustain this moment? Indian government is heavily investing in the. Recently, they had AI summit in Delhi. So they invited world's top leader, OpenAI. So the three major AI center of excellence are already established in healthcare, agriculture, and sustainable development. And with fourth is AI in education, recently announced with the Decide 500 crore budget. That is what government has been initiated, and government mission directly fund fellowship for 8,000 students for UG and 500 for PG. So they are doing very well to take it to new scale, so that we should have digital infrastructure, we should have AI infrastructure, and one day we should have able to describe AI. So what is democratizing AI? So we all talk about democracies, okay? So AI is transforming healthcare, education, government, all sectors. But AI power concentrated in few companies. That is the problems. Only big giant company will running these models. Then what is happening? If computation facility is not accessible to everyone, then what will happen? They will have their monopoly to run their own algorithm and things. So that barrier we need to break, then only. So it is opportunity. Let us make it public infrastructure. Okay, government should do. So everyone can take benefits once it is published. In AI Summit, the motto was AI Summit, Sarvajan Hitai and Sarvajan Sukhai, which translate to welfare of all. So you are thinking how you connect with this ones, how you will do Sarvajan Hitai or Sarvajan Sukhai. AI is there. This reflects the summit core focus on harnessing AI for human-centered progress, inclusive growth. That is, I'm again and again, inclusivity is there. Okay. Now people will have doubt once we are trying to dilute AI so that it can become the democratized, then will happen. So AI should be accessible, affordable, understandable, and usable. Accessible means everyone can get. You should have device so that you can use AI. Affordable, it is not costly, it is not to be big giants, it should be free of cost open source platform. AI is not too difficult to understand in terms of models running and things. We have to be very user-friendly interface and usabilities. Everyone should be get. Okay. So across geographical, language, abilities, and social economy groups. So not just using AI, but also the shaping government and benefit from. So actually democratizing doesn't mean that dilution of quality. It is making expansion to accessible. So Einstein told it's time not to be success, but rather to be values. So that are the pillar. You can see that 6 pillars over there: accessible, affordability, usability, inclusivity, transparent and trustworthy, and governments and ethics. So how you will make accessible to everyone? Open data source, open source models, cloud and edge availabilities, low cost, low resource deployment, mobile, offline, and whatever facility people have in the village. And let us make public infrastructures to run the code and things so that we can have like chaos center. Everywhere you will have chaos centers, you are accessing AI tool used on the smartphone in the rural areas. So we require cheaper and more efficient hardware, open source model, smaller and more efficient, and the commoditization of the cloud AI. That means subscription-based AI service. Now affordability, the low cost of free AI service for social goods. So you have multiple model compression, knowledge distillation, predictive learning, which is making model very complex in this one so that it can run over a small infrastructure. Share public computing resource. That means once you have done, the resource is here to someone. So AI is a service for micro scales, startup, NGO, and also MSMEs. Now coming over that cost efficiency in the AI, which I told that you should be carbon aware of AIs, because the damage which we are making is the magnitude is not to destroying 10 or 1,000 trees. The damage which are doing for next 600 years through AI. So I will show the magnitude. So historically, advancing computation research was restricted to wealthy institutions. Today, the open source movement had drastically lowered the financial barrier to the sector. So you see that India having also our own Saram AI chipsets and our AI models, which is cost effective and accessible solution. We will have global partnership, active player, competitive presence so that we can get low price. We have opened our market to global players also. And impact, we will get the talent pool, we will get the ethical leaderships, and we'll okay. Usabilities. How will make it usable? So no code or low code, very less code we require. We require human-centered design. It should be like for which human is in. NLP interface, the language which you are speaking, same language you can interact with the computer. Okay. Inclusivity, that was the last pillar, but important. Multilinguals, it is not only English speaking people can communicate with the AI. Even though I'm Hindi, English, Bhojpuri, Magai, whatever language or Boli I'm speaking, that to be communicate allowed to. Yesterday I seen that IIC Bangalore professor made very good AI models over this one, which can translate, not translate, can pronounce Sanskrit slok very nicely. Okay. Support for low resource languages. Culturally aware system. And in this way, we'll able to culturally intact our systems. The beauty of India is that we are rich culturally heritage. We have very much diversity. That is what potential we need to. Accessible people with the disability also by different mediums, by eyes tracking, by some other mediums. Speech vision. The last concept was coming transparency. Until this one, they are people and government and will not trust over there. To explain AI how model or AI has predicted, we need to clear documentation model cards, we need to reduce the bias, or we need to mitigate and make aware of this one. Okay. So it is should be fairness and non-discriminatory. We should not use for AI for any unethical purpose, preserving and the AI's accountability and auditability. It is not that something written over internet will not accounted and I'm keep abusing to someone. That to be accountable and same act. I under IT Act 167, this is be liable for same kind of punishment. So we be aware of while we are using digital platform, because first gang rape is also reported in the digital media, where by malicious intention someone has done. Okay, democratize with ethics can amplify harms lost. So government to be very peculiar about this while they are thinking to democratize. They need to think whether we are able to manage ethics, or if something is wrong is happening immediately we need to be cured. Okay, so all section it has access. Social impact, reduce the digital divide. The way society is divided, so like rich people making the 7th floor buildings and poor people staying in the somewhere. So this kind of divided things will not be digital accessible to everyone, empower of the unserved communities, and that is our motive. Any educations having motive to serve the least priority people of the society and bring them to in the main line of society. Faster innovation at the grass level and better public. If AI is not democratized, what will happen? Widening inequality. Only the Reliance and other company will keep running and high people will do. They have opened the center recently, Reliance, where everything's trial room and other things, no need to go. Virtual trial room is there over which you can see. So only big shops will be survived, but small shopkeepers, they will suffer. So by democratizing, everyone can do algorithm, bias, skill, and these also. Okay. So now academic role, because we are from there, so we should have open source and responsibilities. Whatever we code we are writing, it should be given to other also, so that other can reproduce these ones. People can do discoveries, research, student can do to interdisciplinary. We need to connect multiple branches, electronics, electrical, mechanicals, and break that barrier. Ethical leaderships, training future ready talents. Okay. Now coming over this threat, which I think that LLMs, modern AI, OpenAI, Copilot, Perplexity, Cloud, and you see that the student now started writing their project report through this one. But it is not wrong to take help of AI, but it is taking by which extent small kids, their reasoning capabilities, their thinking capabilities getting affected. Okay, their writing, maybe in future they will write the paper through with the help of AI. If some infrastructure is down, that they will not able to do right. Okay, multiple models, BERTs, GPTs, and we are in currently GPT 4.0, which is for especially multimodals. Okay, OpenAI companies which made ChatGPT also realized human computer interaction. So OpenAI made state of art LLM accessible by the simple conversational interface. Beyond chatting, it serves as a rapid. It is just not translating tool. It is for scientific discovery. It is for report writing, question paper writings, preparations, question answering, data analytics. You just provide data, it will generate the things. It will prepare your report within a fraction of a second. And in government decision making process, this must be used AI to take decisions. Okay. For scientific and research purpose, it is different. So you see the penetration of AI percentage. If individual uses, you can see that it is 66% growth of AIs. 78% companies somehow they are using one function of AI. 40% job exposure risks global. If you have AI expertise, so there is good chance of there. Okay. Now coming on what drawback with the LLM of these large language models, then I will conclude with, I will take hardly 2-3 minutes more. The time is getting over. So they have lot of potential, economical also, but the global AI market, if you think the 1.8 trillion by the 2030, and the inference time is becoming so fast, GPT-4 can give you answer of your query in the some 0.3 scale on a daily, billions of queries somewhat in the cost in term. But can you see that carbon cost? The LLM model is estimating 6,26,000 carbon CO2, which we call e-carbon, and we are missing our zero emission of zero net carbon impact. So you can see that if you will compare 5 transatlantic passenger flight per training runs for one AI algorithm runnings, it is like if 5 translated line is passing in the what carbon level emission they are doing this kind of growth. So growth is very, I mean, it is not very, it is substantial. Provide simultaneously declare to non-zero commitment. We want that the carbon emission should zero, whatever carbon we are emitting, that to be solved. And the compression megabytes GPU clusters. Okay. So this is the growth where you see that different AI model, Mina, T5, GPT-3, and this one. You see that there is accelerator years and their energy consumption almost the green peaks. You see the GPT-3. You can assume that. And what carbon wastage we are doing, this we can't do in single country, India, in the 10 year, next 10 year, which they are doing for single AI algorithm. Just I'm making you aware for speed, memory, and this ones, we are doing this ones. Few example, ChatGPT training process may use much water as manufacturing 370 billion megawatt of things. This much of water capacity they will waste. And the CO2e, that means electric wastage of IT. ChatGPT's query use more than 500,000 kilowatt of electricity per day, which is roughly equivalent to the daily power usage of 180,000 US households. So you assume that what magnitude of resources of damage we are doing. Just 120 query equivalent to running a one load of laundries. 90,000 queries equivalent to the round trip flight from San Francisco to Seattle. The energy usage for single request for ChatGPT is equivalent to charging a smartphone 60 times. So I assume that the quantum atom is okay. How we can make energy efficient GPU, we can make low carbon scheduling, GPU optimization, distributed and edge computing, carbon aware, and we have these models. See that, just I want to show some things. If you see that a 13 billion of quantized model deliver 87%, you see that this is 13 billion of parameter and this is 70 million parameter, and the performance is almost, this blue curve is showing the performance gain, almost they are getting same, and the parameter from 13 billion to 70 billions and 170 billion, they are getting similar sort of performance. That means optimized and carbon aware algorithm is performing better. So what we must do, okay, we need to do calling the data center and then power usage effectiveness, we need to check PUC. Okay, this is what silicon evolution, we are moving from GPU to TPU, tensor processing units. Okay, so you see that energy conservations and how much energy they are saving per watts, you can check. Okay, so with this I will conclude, and last I will show the case study, Google DeepMind TPU tensor processing unit versus, and they are using solar integration. So some people has used solar integration for power supply, renewable energies, nuclear power plants, as Elon Musk has done. TPU versus deployment, if you see Gemini 1.5 inference in the TPU is selected regions. Okay, so they are optimal models, cost effective. Some of the data analytics work we also have done. You can see that we are doing some data analytics. We are continuously monitoring the human health while they are working. Okay, so some of these prototype design in our lab, so it is published also in newspaper. Okay, so I have also discussion with in AI summit why to make democratize with the Doordarshan Madhya Pradesh. So with this, I will thanks all the audience, especially Department of Information Technology, JSS Noida, Sukan sir, and other faculty members to giving me opportunity to plan very meticulously and very nicely organize this one day summit. Okay, carbon aware. The carbon is not carbon aware AI is not merely a technology choice. It is responsibility, because environment is our shared responsibility, not so. So this is my homepage. You can scan also, you can find this one, you can connect there also. And with this, I will conclude. Once again, I would like to thanks. So if anyone having any questions, we can have 2-3 queries. Thank you. Thank you.
Thank you, sir.
Thank you.
We now invite the audience to participate in the brief question answer session, and please feel to ask your questions. Yes. Anyone from the audience?
Okay, ma'am, I think that there is no question.
Sir, there is one question. Just a second.
Okay. I'm unable to hear, madam.
Yes, sir. Sir, give us 1 second.
Someone can write in chat box so that I
Yes,
can
sir, I'm
read.
asking them to write in the chat box, sir.
Yeah, ma'am.
Okay, sir. Thank you. So the question is in the chat box.
Okay.
What is the biggest problem in AI that researchers are trying to solve?
Okay. So that already I discussed AI. Those AIs, you are getting computational capability more now from GPU to TPU. Also, we have efficient hardware also now, which is much quantum aware. But in future, we need to think about while we are making this digital infrastructure. Earlier, concrete infrastructure also suffer our society, because in India we make concrete structure. If you go US and other, they have wooden structure. They are damaging environment. Now what we have digital infrastructure, we are making big data center, and you see that cooling effect, managing these big data center will becoming very troublesome in the future. Those computational cost limit will be nothing there. You will get very cheap. The moment we are going for democratize, we are certainly going to damage the society for next 600 400 within 10 years. The way human being is doing, I don't consider that cutting 1,000 trees is making that impact which AI algorithm. So we need to be very selective. Another challenge that our reasoning capability will down. Small kids, some country has banned AI, using AI up to 8 or 10 years while they are growing. Okay, so that they should have reasoning capability, mathematical computation thinking, because you need to become independent thinker. Those AI, I assume that it is actual intelligence, it is not artificial intelligence. The way human being is intelligent, that only AI algorithm is becoming intelligent. But you need to think when to use AI and when not. That is the first question. For public government policies and other, you must use AI. For digital assistant, use AI. But for reasoning, research purpose, academic purpose, try to avoid using AIs. Okay. I hope that I addressed the query.
Thank you, sir.
Yeah.
So there is one more question in the chat box.
Madam, I'm unable to see. Can you read, ma'am? Here.
What makes an AI project stand out to
What?
recruiters?
Stand out.
Yes.
Can you
Stand
repeat?
out.
Ma'am?
What makes an AI project stand out to recruiters?
Two repeaters. That question I did not understand perfectly. Hannah. That is.
Okay, sir. The next question is, as AI adoption accelerate, how should the developers balance innovation with the responsible AI practices?
That is okay. One thing I will tell, so far there is no authorized data in India. Okay, the data which we are getting internet, anyone is able. So the challenge that innovative solution if you are expecting, but how if data is biased, your AI algorithm will not perform better. So, okay, so by until unless we not make authorized data only, then we can't say the predictability of AI is 100%. So for this externalities and other things is required by which you can see how accurately it is prediction. But for critical sections, we can't use AI directly with the help of AI. Sometimes someone in troubles or health cares or space mission, that time it is becoming quite challenging to use directly sole over AIs. So, and another thing that for innovation purpose, AI is okay helping for like modern tasks, which is quite boring task. That time these tools are very beneficial, which human being want to make less effort over there. That times, okay. Yeah.
Okay, sir. Thank
Okay.
you for
Ah.
sharing your valuable knowledge and insight. Your session was highly informative, inspiring, and provided us with a deeper understanding of the topic. We sincerely appreciate your time and guidance.
Okay. Thank
Thank
you.
you
ma'am.
once
Ah,
again, sir. Thank you. So you can stop sharing your screen.
Yeah, ma'am. I'm doing it.
Yes.
I'm disconnecting now.
Hello, I'm audible?
Yes, sir.
Okay.
We now welcome our next speaker of the day, Dr. Pramod Kumar Yadav. Sir, am I audible?
Yes, ma'am. Yes, ma'am. You go ahead.
Dr. Pramod Kumar Yadav is currently working in the Department of Computer Science and Engineering at NIT Srinagar. He has received an Outstanding Faculty Award and Award of Excellence in recognition of outstanding performance and dedication to academics. He has a vast teaching experience of more than a 2 decade and have been granted 3 international patents and published 3 national patents. He has published several research papers in various reputed international conferences and journals. He has also authored 7 textbooks on different computer engineering fields. He has guided several BTech, MTech, and PhD scholars. His area of interest includes machine learning, data science, query optimization, cloud computing, and IoT. On behalf of the organizing committee, I extend our heartfelt welcome for your presence and look forward to an engaging and enriching session. Over to you, sir.
Okay. Thank you, ma'am, for your kind introduction. And let me share my screen over there.
Sir, am I audible? Pramod sir?
Yes, yes, ma'am, you're audible. So, Prachi ma'am, hope my screen is there. My desktop is visible to you.
Yes, sir.
My presentation is visible.
Yes, sir.
Okay. Okay. Thank you, Jasneet Kaurji and Prachi. Now, should I start the presentation?
Yes, sir. You can go ahead.
Okay. Thank you very much. Thank you very much. Okay. So, first of all, I would like to welcome all the participants, those who have joined in this very interesting one-day online summit on data intelligence Nexus 2026. And today, I will be talking about the recent trends and techniques in data analytics and AI. How these particular no data are becoming very important, and how they are helpful, especially for enterprise platform. Once these data which are being generated day by day, what are the core pillars on which any particular enterprise are going to work upon, and how these data will play a vital role, especially when we are going to know take the decision. The decision making for enterprise becomes very critical at certain instant, and in that these data they help a lot over there. So without much delay, I just like to start my presentation with this first very slide, which in itself talks about the core pillars of IT infrastructure. Now, what are the core pillars of IT infrastructure? How a particular IT sector works basically on different types of the data. So you can see there are three different pillars over there. The pillar number one talks about the compute. That word becomes in itself very important when we talk about the data parts over there. And second, which are nowadays becoming very much expensive also, that's what called it as a storage. So that storage also comes over the part over there where we can see how these different database nowadays are coming, and they are coming across, and then they are going to store into different formats of data, where we will talk upon the very important concept of data lakes as well as the data bricks, the new term which have coined recently, especially in terms of database terms over there. A third pillar which talks about the network, where we are going to know connects different systems over there, and they are able to communicate, transmit between computers and the storage layers at different scales over there, where we will use the concept of virtual machines over there and different APIs to connect all these terms over there. So these are the three important pillars of any particular IT infrastructure, where all these are no mutually connected with each others, so that they can give the fruitful results over there. So these are the three very important infrastructure part over there. Now, my next slide, which I'm just showing, will talk about the global data growth. Particularly, we have taken from 2001 to 2025. I mean, a period of decay of almost 2.5 decades. How the data has been uh, generated day by day, and how it has reached to the extreme parts over there. Now, in this, if you see the increase in the volume of the data, starting from gigabytes to the zettabytes over there, and with respect to the years they have spent over there. Also, there are different no types of the data which are growing significantly. there are some data which are unstructured, some which are semi-structured, and then we have structured data. So three different categories. Also, I will talk of these 5 V's of big data which are being very important over there. So here we can see in the early stage where the data was growth over there, they come across the different types over there, where we look upon the unstructured data, which is growing very rapidly over there. For example, text, image, video, audio, social media, documents, and IoT raw data. Now, this IoT again has played a very important role over there, because Internet of Things, as we all know, every person is nowadays connected with more than 1 or 2 IoT devices. Whether it's a mobile phone, whether it's a Bluetooth, whether it is some other devices, home automations, lot of applications have come of these. So day by day, we are now making our life easier by connecting or by making use of these different types of IoT devices. At the same instant of time, we are generating bulk of data also. So we need to handle all these different types of the unstructured data over there. Then we have semi-structured data over there, where they are not having fixed format, but they contain tags or markers. For example, JSON, XML, logs, emails, census data, which are daily generating day by day. And third category, the data which are growing normally, that is the structured data, where organized in a fixed format in rows and columns. For example, we have databases, spreadsheets, transactions, records, salary slips, all those which are in a well-structured form over there. So these are the 3 different types of the data which are growing very significantly. And later on, we need to have certain mechanisms and techniques to handle all these different types of data, so that any enterprise, those who are looking for making any decision based upon this past history, they can look upon the predictions or the classification what these particular data are giving. Based upon that, they can make some certain decisions over there. Now here, if you see the growth of these particular data over there into different fields over there, when early digitizations came, we have GBs of data over there, right? That's what the era from 2001 to 2005 over there, we call it as. Later on, when webs and clouds came, this data has increased to TB part over there. Later on, when mobile and social booms in 2011 to 2015 duration came, again this data become very important and it has grown over there. 16 to 20, when IoT and AI acceleration came, the data again boomed up over there. And now almost the current era which we are living across 2001 to 2005, that's what the era where AI and everywhere data where is being generated day by day. And again, we need to have certain mechanisms to handle all these type of the data parts over there. Now, this 5 V's I'm talking of, big data, basically they have now, these number of V's have been increased also. These are the early stage which we talk about when data grows, the various V's over there. The first very important, that is the volume, which is massive amount of data generated every second over there. These are being growing again day by day over there. Then we have velocity over there, where high speed of data generation and processing is being done over there. Variety is there, veracity is there, and the value is there. Now, value is becoming nowadays very important over there, because we need to understand what is hidden in particular data over. That's what called extracting meaningful insights and business values. So based upon those particular data, or whatever the analysis we are doing in data, we are primarily focusing on what value these data will give to an enterprise over there. So they become very important over there when we talk of the different terms over there. So these are some of the important V's which have nowadays come into picture. And there are certain more V's may be coming up, because as the format of data is being generated day by day, becoming large, and they are being increasing. So probably we'll have some more V's to come over there, and we will be adding over there. But my point was to highlight all these important 5 V's, which plays a very important role to enhance the data part over there. Now, why cloud, parallel, and distributed systems we are talking about, pertaining to especially storage and the processing cost over there. So based upon that, we have these different system or architectures over there, where if you see the problems regarding the storage was the data explosion, which has now moved from gigabyte to zettabyte scales over there. And because of that, this problem arises how to handle all these parts over there. So here comes the picture of cloud, which plays a very important role. Parallel and distributed systems, they are also the parts over there. If you look at these right hand side top corner, the cloud foundation layer, where we have Microsoft Azure, AWS, Amazon, we have web storage part over there. So they're using platforms like Microsoft Azure, Amazon Web Services over there, elastic storage plus compute. So the requirement of data which you need, you can store, you can enlarge, as well as you can enhance and you can store over there. Pay as you use model. So no need to pay because cloud computing always gives you this flexibility. As much as you require the data to need or as much as you want data to take upon, you can pay for that and then you can use that model over there. No upfront infrastructure cost over there. So if you are going for an enterprise to develop or you are looking for a startup, these particular types of the platform will help us a lot in getting these particular parts over there. So it enables both storage and processing at a scale over there. That's the key takeaways which you can point over there, where we have this first part, that's what called cloud foundation layer over there. Then we have parallel processing, where we have different GPUs, CPUs, which are being connected over there. And then they are best for image processing and machine learning analytics. So nowadays, this term machine learning, deep learning, XML learning, all these terms which have been coined, these are because of the systems which are getting faster image processing over there. And parallelly, we are getting those results in this part. The third is the distributed systems, where we have scale layers parts over there using Apache Spark, splits data across multiple machines over there, processing big data in clusters over there. So they have again a very important aspects over there, which takes away over there. So here, component, if you take the key differences between these two parts over there, the key insight comparison pertaining to the cost with these parts over there. Low, medium here we have, then here we have high parts over there. Then why they are there? They're cheaper as per GB, scalable on demand, optimized for long-term storage and commodity hardware. So these are some of the use case examples where we can take backups. We can have data lakes, archive, media storage. Whereas if we talk about the application part where we can look upon for parallel processing and distributed, it requires CPU and GPU, memory, clusters and network overheads over there. So there are different use case examples where we use real-time analytics, image video processing and scientific simulations. So these are certain types of the use case examples where we normally use the concept of the parallel and distributed systems. Now, if you take the key takeaways from this particular point, what it talks about is clouds provides a foundation for elastic storage and compute. Parallel processing delivers the speed for compute-intensive tasks. Distributed systems provides scalable to handle petabyte and zettabyte data efficiently. And together, they solve the challenges of data explosion with the right balance of cost, speed, and scale. So these are the key takeaways which we can think upon. Why these particular terms, they are very important over here. Data generations by world regions 2025. If you look upon the regional breakdown, Middle East and Africa, they are looking for 5%, then Latin America, Europe, North America, and Asia Pacific. So we are the parts over there where we are generating bulk of data over there. So and the factors which are there, look at these at the parts over there where we have cloud parts over there. The IoT sensors, these are some of the areas which they are talking about through which the data is being generated day by day over there. Then how data is processed over there. So here we can see we have three verticals. The batch processing, which was slow and took a lot of time over there for processing a particular data over there. Process large volume of data collected over a period of time. Job runs on a schedule over there. So latency was very high and throughput was also very high. So here you can see we have Apache Spark, AWS Glue, Databricks Jobs, Hadoop, and MapReduce. Then we have these terms called stream processing. This is another way of processing the data over there, where processes data in a real time as it flows in. Events are analyzed individually or in a micro batches, small batches over there, and these data they are being part over there. Latency here is very low over there, and throughput is a moderate over there. But if you talk of the hybrid model, which we call it as a lambda, it combines batch and stream layers, both batch for accuracy stream and stream for speed over there. So it serves merged view over there of these previous two tasks over there, where latency is also low, as well as throughput is also high over there. Here comes the concept of the Databricks Lakehouse, Delta Live tables, and Apache Storm over there. So these are some of the ways through which we are going to process data over there. The modern cloud computing landscape, where we have these different parts over there: multi-cloud strategy, edge computing, storage devices, cloud security. Then cloud computing in 202, these are the top trends which are coming up with the AI ML integration over there. Edge computing, where we are looking for faster processing data near the users for low latency applications also. Cloud security also. Serverless computing, where we are looking for, and multi-cloud strategy. Now this part over there where we see the architecture and the future of data plus AI. So how these data which are being generated day by day are going to map with the artificial intelligence, the concept of AI when we are going to look upon. There comes the concept of the Databricks over there. So you can see the annual revenue of $1.6 billion, more than that, 10,000 plus customers over there. And we have three major cloud providers over there, one data and AI platforms, where we can look upon all these pros and cons of Databricks over there. So what basically is a Databricks? Let's see, and then we'll discuss upon how they are going to help us into a analysis part of the databases over there. So it's a unified open analytics platform built on Apache Spark that enables data engineers, data scientists, and ML engineers to collaborate and build data-intensive applications faster. Now, that is the prime role why we are coming across with Databricks, which has a now a term coined into the market of the data analytics part over there, the Databricks over there. So data engineering is there, we have data science and ML, and then we have SQL analytics over there. So let us see in data engineering, it builds reliable data pipelines with delta lakes, autoloaders, and DLT part over there. Whereas data sciences and ML, they have a collaborative notebook, ML flows, feature stores, and model serving, Databricks SQL for business intelligence, dashboards, ad hoc queries, and data warehouse. Now this BI, nowadays again, if I talk about this, most of the successful business, they are work on these particular parts over there, where these Databricks are playing a very vital role, especially when you talk about the business intelligence part over there. So work seamlessly with Apache Spark, Delta Lake, Machine Learning Flow, Unity Catalog, AWS, and Terraform. Then if you see the architecture of the lakehouse, it's combining the best of data warehouses plus the data lakes. So as we all know, we have real life lakes full of water. Similarly, we have data lakes which is full of data, healthy data, which is being helpful in getting the decision parts over there. So we have data engineering, machine learning, SQL analytics, and streaming data. Streaming data, the data which is being looked upon for real life part over there. So these are the points you can see how this Delta Lakes open tablet format is there, Apache Spark, distributed computing, Unity Catalog, data governance and security, cloud storage. These are the various areas where we can think upon. The open source storage layer, the Delta Lake part over there, where we have the ACID properties over there, schema enforcement, scalable metadata, DML supports, unified batch plus streaming, and time travel. These are the parts over there where they combine together, and then they are going to discuss how they are going to look upon different formats of the data over there. The full ACID guarantees on cloud object stores, no more partial writes or corrupt data. ACID transactions, as we all know, the very important property of any particular transaction, that's what called ACID: atomicity, consistency, isolation, and durability. The very basic concept which we all know pertaining to any transactions. If they need to follow all these property. In short, we call it as the SE properties: atomicity, consistency, isolation, and durability. Then there's a schema enforcement also for this. Schema is basically the overall logical design of a database. We call it as schema. Whereas once you put some values or provide some values to that particular schema, that becomes the instance. That's what we call it as schema and instances over there. So there's a schema enforcement over there. Whatever the structures over there, automatic schema validation and writes evolves the schema safely without breaking pipelines. So these are the important characteristics, especially for the Delta Lakes parts over there. Now, the Mendelian architecture for enterprise data platforms. Now, this is again the journey which has taken place across 2 decades, and many data governance at a scales, they looked upon all these over there. How we are going to look on these parts. So here also we have categorized these into 3 different parts over there: the bronze, silver, and gold. So now the era is of gold over there, where we are looking upon how these particular techniques, they are going to help and make an enterprise to make certain decisions over there. That's what we call it as Mendelian architecture for enterprise data platform. So this particular architecture again is helping most of the enterprises, most of the industries, most of the organizations to better take decisions over there. And then they looked upon how these data are going to be analyzed over there. That's very important over there. So if you see the left-hand sides over there, the source systems where we have ERP, we have IoT oblique sensors, APIs, SAS, streaming, file batches, legacy DB, click streams. So all these different data which are being generated over there. And at the consumer side, you can see we have business intelligence tools which are now working and which are taking input to these data, and then they're coming across certain decisions over there. We have tabular tools over there. We have ML AI also. We have APIs. We have execution dash. We have audits, and then we have regulator sort of things. So these are the key parts or tools across the consumer sites which are being getting these data, and then they are going to take some analysis of how or what message or what particular values which are being hidden inside these particular data. So Databricks workflows, architecture, schedule jobs over there. So we have triggers over there. There are different tasks. Task 1 is to file inject over there. Then task 2 is to transform them. Then third is to validate and then load to deltas and then notify or report. The report is the core part where we are looking upon how these different Databricks, they are going to work. And then the flow of the data from one place to another over there. So con expressions over there, run daily at 6 p.m. over there, API event triggers over there, how they are going to looked upon. And then we have file arrival triggers and continuous modes over there. So these are some of the different aspects or the scheduling options which will make our job easier. Now, these are some of the hands-on over there. If we can work into that over there, where we can look upon how to take upon and how to take this activity parts over there, where we can build a data pipeline over there. So we need to have set up Databricks community editions, where we can create free account at community.cloud.databricks.com. So create clusters and then open notebooks over there. So these are the ways through which we can know takeaways over there. And then we have step 2, where we can do on the hands up over there to create sample files in DBFS, call an API over there. Once we use that, upload the CSV or JSON files to these file stores, tables, using the UI or percentage hash rate, the commands over there. Then we configure autoloader source, pipeline Databricks notebooks, where we write a read streams notebook hand reading from DBS using cloud files format with schema inferences over there. The next step 4th is to create Databricks workflow job, where we can use the pipeline ADF, and then we can take upon the Databricks notebooks over there. And then run and inspect data table results. So that's the last options over there, where we can look upon how these particular Databricks, they are going to help upon. Then Snowflake is another term which has nowadays coming. Another architecture which we discuss over there, the future of data platforms, which are coming across over there, the Snowflakes, where annual revenue $3 billion over there, you can see, and a lot of customers are growing again. And then there's one cloud platforms parts over there. Now here you can see in the Snowflake, it's a lakehouse platform where data sources are there at one end, and at the other we have the data consumers over there. So OLTP databases, as we all know, the data which are in transaction, online transaction processing databases, enterprise applications, third party, weblog, and then we have IoT. In between, we have a Snowflake. And then at the right hand side, you can see there are different data consumers, data monetizations, operational reporting, ad hoc analysis, and real time analytics. Now, in between these bricks, it's just like a brick parts over there, which we call it as. So these data bricks again become very important, which is a Snowflake, where it handles all the subsequent part or major subcomponent of the data analysis parts over there. Just like we have data engineering, data lake, data warehouses, data science, data applications, and data exchange. So they all combine together in the initial part of the data, which is being given fed as an input. And then at the right hand side, the output, or what you can call it as the real-time analytics of these data is being done with the help of these Snowflake. And at the bottom level, you can see we have the Google Clouds, AWS, and Azure. So these are the different softwares which are being helping us in making these particular terms in important parts over there. So this is the architecture of the Snowflake layer architecture, we call it as. At the top, we have the cloud services, then we have query processing and database storage. It is very similar note to, if you see the database structures over there, overall database structures, storage structures. So at the top, we have different cloud services over there, where authentication and access controls are there. And in between, we have infrastructure managers, optimizers, metadata managers, and security. These are the top level managements over there, where a lot of cloud services are also there. And in between, we have the query processing, where the virtual warehouses are being connected, and then they are dependent upon the databases which are at the storage levels over there. So these storage level data helps us to make these particular parts or this particular querying. So once we are querying particular data, these databases storage helps them as an input, and then with the help of all these, we are looking upon on the output part over there. Now, what is the problem with the traditional warehouses? Why we are moving ahead and why we are looking for new terms or new particular techniques to handle different databases over there? The very first and very important, that's Oracle over there. Then we have SQL servers. We have terabytes of data over there and built for yesterday's worlds over there. Now, some of the pitfalls which can looked upon over there regarding this Oracle, if we talk of the databases over there, the very first is the slow to scale. That's why we see the symbol of tortoise. But yes, scaling required buying new hardwares, weeks of planning, not a minutes of clicking. So that is one of the pitfalls normally we are looking for. Then we have hard to maintain over there. Large DBA teams needed for tuning, patching, and performance optimization. Now, these are some of the key terms which use normally in software industries over there. Tuning and patching and performance of the operation parts over there, where database administrators, they had a core team which looks upon all these parts over there. Expensive licensing, that is another very prawn area where we can see, where we can have we need to invest huge amount, especially when we need to purchase the license of these parts over there. Structured only. That is also one of the key points over there, where they looked or they work only for the structured sort of data over there. If you have structures, semi-structured, or unstructured, normally we'll have different parts over there. No real-time parts over there. So batch only processing hours old data in an era demanding seconds over there. Vendor locking. On-premise migrations were painful, costly multi-users projects over there. So these are some of the keywords, pros, due to which these traditional problems warehouse they are looking upon. So we had the Snowflake architecture, the secrets which decouples compute from storage parts over there. Cloud services layers. Then we have query processing layers and the cloud storage layers. They need to work upon over there. Instant elasticity, pay per use over there, any data format, enterprise security, and multi-cloud native over there. So these could be the, you can say, the advantage to the traditional data warehouses over there, where we are facing certain issues, and now they have been cope up with these different snowflake architecture of the databases parts over there. So instant elasticity, again, scale virtual warehouse up and down in seconds independently. We can do that part over there. They provide us the freedom, what we see, they provide us the flexibility to instantly elaborate over there. Pay per use only the parts over there. Only pay for compute while requires queries, which are not in ideal parts over there. Structures, semi-structures, and unstructured. So all different formats of data can also be handled by the Snowflake architectures parts over there. And they have enterprise security. That's very important over there. So they had end-to-end encryptions, row column security, and data masking. This data masking also becoming very important nowadays. So they need to be looked upon, especially pertaining to the security of the enterprise parts over there. And we have multi-cloud native over there, where they can run on AWS, Azure, or other particular parts simultaneously. So the Snowflake regions is the data cloud, where beyond the data warehouse, becoming a global data ecosystem. So these are the points where they are taking into these snowflakes into much more important concepts over there. The very first point is the data marketplace, where 3,000 plus live data sets from providers like Bloomberg's, Refinity's, and weather services, no data movement needed over there. Secure data sharing, share live data with partners, customers, or subsidiaries. They require your data, they query your data directly, no exports, no copies. So these are some of the, important features which Snowflake Vision has taken over there, due to which these data, now we are moving toward these Snowflake parts over there. And very important, this AI and ML workloads. The Snowpark for Python, Java, Scala, Cortex AI for built-in LLMs, train models where your data already lives. So these are the features which nowadays this Snowflake's Vision data they are being providing us, and to do with that only they are becoming very much important over there. Unified analytics over there, one platform for BI, data science, data engineering, and application development, break data. So there are combined applications over there where large data can be combined together, and then they can look upon over there. So it provides, so you can say, a combined unification, or combinedly large number of users can join to look upon and to make analysis for all these different types of the users at one particular platform. Cross cloud collaboration. Now that is also one of the important features of Snowflake's, which they can look upon over there. So data sharing across AWS, Azure, and GCP regions, first ever trust through multi-cloud data parts. Governance building, unified data catalog, policy engine, access controls, compliance, not bolted on, built in. So these are some of the key points which we'll look upon for the Snowflake parts over there. The two giants, but having different DNAs. Now, again, the time era has come to have no comparative analysis between these two parts. These are the two different joints, but having different DNAs with them. The Snowflake versus Databricks. So Snowflake founded in 2002, and Bricks came after that in 2013. So in Snowflakes, we see we have cloud native data warehouse analytics, whereas in Databricks, we have unified data plus AI plus ML platforms. That's called Lakehouse. And that's why now this Databricks also, especially depending upon the applications pertaining to AI and ML, they are very much used over there. Storage, compute separations, which is called elastic scale. Here we have built on Apache Spark and Delta Lakes over there. Optimized for SQL and business intelligence workload, optimized for ML and AI streaming. Now here with this distinction between these two, or difference between these two giants, you can see the different types of the enterprise. Depending upon that, they may take these two particular applications parts over there. Data sharing and marketplace leaders, we have these Pythons are Scala, not SQL first over there. Cortex AI for built-in LLM features, large language model. Nowadays, LLM are also becoming parts over there. So here ML flows for end-to-end ML life cycles, zero copying, cloning, and time travel. And here we have DBRX, open source LLM, and Gen AI tooling. Then head-to-head key differences in terms of primary use case, query languages, data architecture, streaming support, ML AI, cost model, setup complexity, data sharing, governance, and best for teams. So if you look at these parts over there, here we can divide these parts over there. The data warehousing and analytics parts, there we can look upon. In terms of bricks, we are considering primarily the use cases pertaining to AI and ML and data engineering parts over there. If you look upon the query language, SQL first, then answering SQL, whereas here we are using PySpark, SQL, Scala, and R. Cloud data warehouses, where the architecture Snowflake they used to follow, whereas in terms of Databricks, it has the whole architecture which is called as Delta Lake or Data Lake House. Streaming supports they have very limited, whereas they have native Spark streaming over there. ML and AI, Cortex AI, Snowpark, ML Flow, DBRX, and AutoML over there. Pre-credit. Then we have Databricks unit. They are very important again, DBU. Setup complexity here is very low. Here it is moderate because they have customer configuration. So that's why the Databricks have moderate setup complexity over there. Best in class market as a data sharing, whereas data sharing open source over there. So that's again makes a open source software, so makes more popular among the users over there or consumers. So they are more lean towards using Databricks over there in the application part. Governance, they have native origins. There are parts. These are some of the head-to-head key differences between these two big giants over there. The pros and cons, if you look upon the advantage over there, in these two giants over there, in Snowflake, the advantage is the zero infrastructure management, instant scale up down for per query, best in class data sharing, handless structures plus semi structures, strong SQL support for analytics, and multi cloud cross region over there. Whereas if you look upon the advantage of Databricks, the industry leading ML and AI platform. Native Apache Spark performance, open source at heart, excellent streaming and real time, ML flow for complete ML lifecycle, and flexible multi-language support. These are the advantages among these. If you look upon the disadvantages, Snowflake has the disadvantage that it can get expensive at high scale, whereas it has a limited native streaming support. MLAI capabilities still maturing, less flexible for a customer Spark job, vendor lock-in risk propriety over there, not ideal for complex ML part. Whereas the disadvantages, if we talk about database parts over there, there are higher learning curves, more complex cluster management, SQL queries slower than Snowflake, business intelligence analyzed, experiences less polished. So they need to have more better analysis results of the data which are being there over there. Cost prediction higher, and data sharing less mature over there. Now, point comes when to use which platform. So if you choose based on your team, data strategy, and workload, so we need to work upon over there. So these are certain points, or you can say certain instance or condition under which we need to work for Snowflake, or we need to look upon Databricks over there. So choose Snowflake when business intelligence and reportings are required over there. Your team runs SQL dashboards, Tableau, Power BI, or Looker over there, where enterprise data warehouse migration is there, moving from Oracle, Teradata, or SQL Server to the cloud, data sharing across organizations to share live data with external partners, clients, or subsidiaries, and multi-cloud data strategies. Whereas the need for Databricks is machine learning and AI development. So if you are looking for a platform or applications where you are going to look upon the applications pertaining to AI and ML, in that case we can work on the Databricks parts over there. Then if you are looking for real-time streaming pipelines over there, so Kafka injections, IoT data, fraud detections in milliseconds. So where the data criticality is there, in that cases we can need or we can look upon the real-time steerings of these parts over there to Databricks over there. Data science teams over there where we have Jupyter's notebooks, Python, R analysis, or raw data at scales, and complex ETL and data engineering. In those particular cases also, we can use Databricks parts. So who are the other competitors where we can look upon the competitors parts over there? Oracle databases, Teradata, Azure, Databricks, Snowflake, Amazon Redshift, Google BigQueries, and Microsoft SQL servers over there. The complete competition landscapes, Snowflake is not alone, but leads in a key areas over there. So you can see the Databricks, Azure Snapshot, Snowflake, Amazon Redshift, and Google BigQueries. Now these are some of the real life examples where we can look upon how much they are going to know looked upon over there. So Snowflake, if you look to see, it outperforms the above all with 95% of the applications areas over there. So it leads in the key areas over there with all these different types of the competitors which are available, and they are being looking upon over there. So Databricks also parts where we can see best in class of MLAI, Apache Spark, Delta Lake, Lakehouse architecture, strong for data science teams over there. Whereas these are best pairings for the strongest SQL performance, easiest systems over there. So Snowflake outperforms the above all. These are some of the hands-on which you can carry on, which you can work upon over there if time permits over there. So where you can set up these Snowflake free versions, you can go to these particular links and you can download over there. Create that databases and warehouses. Create that virtual warehouses. We can compute, and then we can put upon these particular values over there where you can create databases and schema for that particular table over there. And then create that table and insert some sample data and query data time travel to clone tables. So zero copy clone over there where we can look upon these particular parts, especially pertaining to the Snowflake and the hands-on parts over there. So key takeaways, what we have learned today, that could be caught over there. The cloud computing landscapes, why cloud computing and its components parts over there. Modern data architectures, cloud skills, Databricks versus Snowflake. So that is the key focus which we have put over there. How these particular terms which have been coined in recent, how they are going to help in making an enterprise to make a decision parts over there. So the future of data plus AI plus data processing, and Snowflake, the cloud data platforms where they are looking upon and how they are going to help in these particular parts over there. If you talk of the career growths over there, the Databricks, Sparks, and cloud certifications are among the most in demand skills globally in 2026. So if you are looking for working into these industry parts especially, so these type of certifications also helps a lot over there, where we can get hands-on on all these applications, and then they can look upon these certain skills to enhance, to look upon how to develop all these particular features over there. So end-to-end views of the modern data architectures parts over there, where we can see how we are going to be looking upon over there, ingest, store, process, verify, and then serve over there. Now this last serve where we have BI, ML, APIs, and dashboard. Nowadays, they are becoming very important, and these particular data of the analysis parts where we are looking for the business intelligence, whether it is machine learning or it is APIs, these dashboards, they all depend upon these previous folders, or we can say the previous vertical columns which are being important over there. So to store, and then to process, and then to verify, and then to get that. So here, key takeaways if you see is the data doubles every 2 years. The scalable architecture is essential. Now, if your database is scalable, and then only it can survive. Else, there will be no need of such types of databases in the coming eras, because the data every years which are being generated is becoming doubles of it. Choose the database type based on consistency, scale, and query patterns. Stream processing for real-time batch processing. Data quality. Now that is also very important. The data quality should be there. Accuracy, completeness, timeless, driverless, reliable insights. So these could be the key takeaways from end-to-end views, where we can see how these parts were there, especially this quality of data, because now we have a large amount of data, bulk amount of data available, but they are having no noise. They contain some noisy, or what you call it as the data which are not pertaining to that particular structure over there. So the more better data is, the more better results will be there. So if you want better analysis, in that case you need to have better data part over there. Else the results will be not good. And that's why we use that term, which we call it as data pre-processing. So before getting the data, or before getting to analysis of data, the pre-processing of data is very important. So in that case, we need to remove all those noises which are being present in the databases, so that data becomes of best quality, so that that can be utilized and that can be easily used to take some decision parts over there. So here we have this metadata convergence over there, where we can see data storage, data processing, ETL, and then analytics, AI and ML parts over there. So how these different fields they are looked upon, and then they are going to help into taking the decision parts over there. So skill for futures, we are looking over there, where we can look upon Python and SQLs, cloud platforms have become very important nowadays. And AI ML integration also, they are going to speed up over there. So AI native cloud platforms, future of clouds, quantum computing, autonomous cloud systems, and hybrid generates. So this line is very important. Who blends cloud plus data plus AI expertise with strong system decision thinking. That is a key takeaway, that the future belongs to professionals who blend the cloud plus data plus AI. I mean, they can incorporate, or they can develop a model which can incorporate or make some combination utility of these three terms: cloud, data plus AI expertise, so that they can use these particular data for taking some business intelligence, or for making decision of business intelligence or enterprise parts of it. So that's all from my side.
Thank you, sir.
Thank you, sir.
Now I invite our participants to ask any questions in the chat box. Sir, we have a question.
Yeah, Abhishek, he has written one very good questions over there. How AI models? Yeah. What the questions over there? It has got. Okay, I can see from chat. AI model becomes larger. How is the cloud computing changing the way we build AI applications? Now, see, most of the AI application, if you look upon over there, they all are dependent upon the type of data which are becoming day by day important over there. So, if any application is there, the very first thing is they should have a good database, or the bulk of data which can be looked upon. So based on those data only, they can be able to predict, or they can able to classify any particular problems over there. For example, if I talk of the weather forecasting system of our country itself, so nowadays the systems or the weather forecasting, they are becoming very important, because we have a very good amount of history data present over there. So based upon that only, we are able to make over there. And cloud has become one of the very important era in today's world, where lot of data are being kept over there. Especially if we talk of these cloud data centers, the very term which I can correlate here, which will be much appropriate. These cloud data centers are a backbone to various AI applications, because AI, what they are doing is artificial intelligence. Basically, when they come across any sort of decision making, So they all based upon the type of the data which are being provided or which they can retrieve from these different cloud sources over there. So that's why this cloud computing, they're becoming a way, or they're showing a path, we can say, to these AI applications parts of it. And one more question is from Tanushi. Why are companies moving from traditional databases to the cloud plus database platform? Very good questions over there, Tanushi. The only one term which I can talk upon, or we can say that the movement of these traditional databases towards the cloud is the investment of the cost, the ease of handling the databases, the ease of scaling the database. These are some of the important features which cloud computing has. Due to that, these traditional databases are coming to an extent over there. No organizations or companies nowadays, they want to look upon all these terms over there. That's the reason why most of the organizations or most of the companies are moving towards the cloud databases platforms parts over there to make their organizations work in a much better way, or whenever they want, they can scale up, they can move, even shift their data centers also from one place to another. So all these things, they are becoming helpful for the organizations to get away from these traditional data warehouses over there. Then Jyotirmay Singh is asking, sir, what are the things we should avoid as a beginner in the cloud engineering? Yeah, as a beginner in the cloud engineering, the very first things you need to choose the correct cloud platforms or authentic platforms where the data which you are getting, they must be authenticated. Now, I have heard a lot of research scholars, mine, they are working, or many of you also, people, those who are working for research and all, once you are using for the, any result analysis, the very first name which you get to get data from Kaggle, a very famous, online platform where you can get large bulk of data over there. So that is what the first thing is. We should be, look for a good particular data or a best quality of data where data is present in a better quality, not the fake data or these types of data which are generated over there. So once we are starting in beginners as a cloud computing or cloud engineers, you need to first select a very best particular platform through which you can collect the data. And that is very important over there. Because if you do not if you don't have a quality data, the results or the analysis or any particular in the what you can call conclusion which you are going to make will be hampered over there. So if the best quality data, the best result you will get. If the data is not of good quality and you get the best result, in later its accuracy will fail over there, or its precision maybe fails over there. So once we are starting in that part over there, you need to first look upon what type of data are available and what are the different platforms. The very common platform which I find every scholar is to look upon is the Kaggle. They will say, yes, sir, there's a past history, 10 data, 10,000 bulk of data is available on Kaggle. But we are not sure whether that data is pertaining to our country or to other countries. So once we are looking for a particular data, we should look on all these parts over there.
Thank you so much, sir, for your insightful and inspiring lecture. Your valuable knowledge and expertise have made this session truly enriching for all of us. Thank you for your valuable time and contribution.
Thank you, and thanks a lot.
Now I welcome our next speaker of this session, Mr. Sparsh Pandey. Sir, am I audible?
Yes, ma'am, you're audible. Good afternoon, everyone.
Very good afternoon, sir. Sir works as a technical service engineer at MongoDB, where a big part of his job is keeping large, complex data system running smoothly for companies that simply cannot afford downtime, named like IBM, Citibank, LinkedIn, and Anthropic. Mr. Sparsh has completed his MTech in cloud computing from BIX Pilani and has previously worked with Nagaro and Couchbase. He is also a certified cloud a Google Cloud architect, and over the years, he has spent a lot of time hands on with the distributed data systems that quietly run behind the AI we keep hearing about. On behalf of the organizing committee, I extend our heartfelt welcome for your presence and look forward to an engaging and enriching session. Over to you, sir.
Thank you, ma'am, for the introduction. I'll just share my screen. Just let me know if my screen is visible.
Yes, it is visible, sir.
Thank you. So, without further ado, we'll get started. Good afternoon to everyone who is present in the Zoom. First of all, a big thanks to Dr. Lavkush Sharma and the Department of Information Technology for having me here today. And for the next 35 minutes or so, I will be talking about data, but not data as a buzzword. I want to talk about data actually doing work, where it sits inside real systems across four very different industries. And without further ado, let's get started. Yep. So a quick background on where I'm coming from. As my introduction told, I work as a technical services engineer at MongoDB. So most of this presentation is going to be an engineer's view and not a product pitch. So my daily work is to keep large data systems healthy for companies where downtime is simply not an option. When you do that across banking, tech, and a few other sectors, right, you start noticing subtle patterns. While the surface problem may look different, but underneath, what I see is that the same data problems keep rhyming everywhere. So basically, that one observation is basically going to be the whole talk for this session. Moving over to the next slide, this is the agenda on what we will be covering. So basically, we shall first review two simple mental models, and then we'll keep coming back to them again and again. So please hold on to them. And then we will walk through four real case studies using the same lens on each one, so that by the end you can compare them side by side. And then we'll look at a couple of India specific examples if time permits, and then we'll close with the hard parts and where all of this is going to head into the future. So moving over. This is the core problem, right? Let us frame the real question first before we deep dive further. Almost every organization today we see, right, is sitting on a mountain of data. Data is literally everywhere. Like in the previous presentation, also sir was suggesting, right, Kaggle. So a lot of data is available on Kaggle, but we don't know where that is coming from. So looking at the enterprises today, the data they hold is really enormous. They are sitting on a big mountain of data, but very few of those enterprises are sitting on a mountain of good decisions. So there is that gap, right, between having data and actually deciding something with it. And that is where all the value hides in today's scenario. For example, if we build a dashboard, right, with a lot of metrics and beautiful charts, and but no one looks at it is just basically an expensive screensaver. So looking at the story of the last 10 years, we see a shift. First, we use data to describe what happened, then to predict what will happen, and now more and more the system decides itself and acts. Let's look at the mental problems first, mental models first, and then we will move over to the case studies. So this slide, the data intelligence maturity curve, this is the most important slide for today. So let us slow down a bit here, right? We'll discuss all these five stages in this slide, and then we'll keep linking them back to each of the case studies we are going to discuss further. So if you see, like the stage one, descriptive, it just tells us what happened. Stage two, which is the diagnostic stage, it tells us why it happened. And stage three, predictive stage, it tells us what is likely to happen next, which was like the point of discussion for over past 10 years or so. That is, we were at the descriptive and diagnostic stage, and we kept coming back to the predictive stage over the past 10 years. But now this curve has moved ahead, right? Looking at the stage 4, which is prescriptive, which actually recommends what we should do about it. So once we have made the prediction, we need to decide what best decision should be done about that prediction, so that we are prepared. And stage 5 is autonomous, which sort of closes the loop. The system takes the action itself, and the human only supervises it. Now, if we notice two things as we move from left to right: one, the business value keeps going up; two, the time to decide collapses from days and weeks down to milliseconds. So, for example, for every case studies we are reviewing today, we'll stop and point out exactly where on this curve that study is sitting today. And here is the honest truth, right? Most real enterprises are still stuck between stage 1 and 3, like we discussed. They are still struggling with stage 4 and 5. Moving over to the next mental model for today, anatomy of data in action. And after that, we'll go into the real examples, right? So if we strip away the industry, almost every data-driven system has the same skeleton, which is visible in the form of these boxes on the screen, right? You ingest data from many sources. You store it, usually a mix of historical store and a fast real-time store. Then you clean and process the data, you run a model on it, and you serve that model's output into some application. Something or someone then acts on it. And then the part which people or enterprises mostly forget is the outcome comes back as fresh data and retrains the model. So if you see on the right hand side of the screen, right, after acting, that outcome is going back into the model as a feedback loop, which keeps on improving the model over time. So this last loop is the whole game today in the enterprise world. So let's move over to some of the real case studies now. We will be discussing 4 industries, and we'll see that the same lens is applied to each, which is the last part we discussed, right? Data source, model action, and then that loop which we reviewed in the previous slide. So the 4 industries we are going to discuss today are healthcare, fintech, smart cities, and retail. Uh, Moving over to the healthcare industry, right? We start with healthcare, and I've picked up one very specific, very hard problem, which is sepsis, right? To give a brief background of what is sepsis, because I understand like people here are not from a medical background, neither am I. So sepsis is the body's extreme reaction to an infection. It can cascade into organ failure very fast, and it is one of the biggest killers inside hospitals if we look at the numbers, right? But the interesting part here is if you catch it early, it is very, very treatable. But if you catch it late, it is often very fatal. Now, here is what makes it a beautiful data problem. Whatever data, signals, vitals, lab values, etc., whatever you need, right? All of that is already being recorded in your electronic health records. For example, even if you get a blood test done today, most of these companies provide you the report online, right? So that data is just sitting there in your electronic health record. So if we have to solve this problem, we don't have anything new to collect. The entire problem is pulling the signal out of the noise in real time before it is too late, because more often than not, in such cases, it is a race against time. So if we try to word it, it is a pure data in action problem. Uh, let's see how this case study looks like. Moving over to the next slide. Yeah. So if you see, now map this into our pipeline, right? The data source is a live feed from the hospital's electronic health record. And the model is a real deployed system called Composer. And this case study was performed at UC San Diego Healthcare Hospital in the US, right? So this Composer, it is a feed-forward deep neural network, watching more than 150 variables per patient continuously. Let me give you one more clever engineering detail. So if you look at the third point, right, conformal, intermediate, flag, suppresses, false alarm. So this was one very interesting feature of this model is that it has a conformal prediction module. So In plain terms, what it means is when a patient's data looks unlike anything the model was trained on, it does not panic and fire a random alert. It basically says indeterminate and simply stays quiet. So that one design choice, how it helps is it basically keeps the false alarms down. And false alarms are exactly what makes doctors switch these systems off. For example, if I were to build a system for healthcare and it kept firing false alarms, wasting the time of doctors and nurses, right? Sooner or later, they'll be tempted to turn that system off. But in this case, what was happening is that either it will say with surety that I expect a 90% prediction that this patient has a risk of sepsis. If that is the case. Otherwise, if it is not able to determine anything, it will simply say indeterministic and leave it to the best judgment of the medical health professionals and won't give a false alarm, right? And if we notice the action, it does not push medicine into anyone. It simply alerts the medical system. It basically alerts the nurse who loops in the physician. So in this design, right, a human stays in the loop. Now, if we talk about the results of this case study, how it helped, right? After Composer went live as part of this case study, there was about a 17% relative reduction in hospital sepsis deaths, along with better compliance on treatment steps and less organ damage at 72 hours. This was also tested at a separate system from John Hopkins called TRUES. And this was studied across 5 hospitals covering near 6 lakh patients. And when the doctor acted on the alert quickly, antibiotics reached the patient almost 2 hours sooner. 2 hours may sound a bit less, but in case of extreme sepsis and medical emergencies, 2 hours is an enormous time. So where does the healthcare sit on the curve, which we discussed in our second mental model, right? It is predictive, moving into the prescriptive zone slowly. That is, the machine predicts and recommends, but a human takes the final call. And in a life and death setting, right, this is exactly where it should be. We are not ready to hand this fully to a machine. Let's move over to a next case study for the day. This is basically across the fintech industry, right? And the biggest issue in fintech industry today is basically fraud detection. And this is a lovely data problem, and it is the exact opposite of the hospital case. So basically, 3 things make it hard. The first one is fraud is extremely rare compared to genuine transactions, right? So if we sort of look at the number of frauds happening around us, it seems to feel that the number of frauds is extremely large. That is, if you search across India yesterday only, right, you would see thousands and thousands of frauds. So it gives us an impression that the fraudulent transaction data is way too large. But if you compare it with a number of genuine transaction, it comes out to be a very less fraction. For example, 1 in 1 lakh or 1 in 50,000 transactions, right? So most of the transactions are genuine, but the fraudulent transactions are very rare. So what does this do? It basically makes the data wildly imbalanced. And what will happen if I create a lazy model that just says everything is fine? It can look 99% accurate and be completely useless, because in one of those 10,000 cases where it is fraud, and if it does not predict that, right, it is completely useless, but it sits with a very high accuracy, because most of the transactions which are not fraud, it is telling they are not fraud. So it is right on those cases, but it is not helping in any way. The second problem is simple rule-based systems catch the obvious frauds cheaply, but the expensive, clever frauds change its shape every week. We know, right? The fraudulent systems are adapting with time, and we keep on hearing about new and new frauds. So they keep evolving. So if we were to build a system which can help us detect and predict these frauds, the same rules of evolvement will have to be applied on our system as well. It can't be just sitting there being prepared like 5 years ago with all those older fraudulent methods, right? And if we look at the third pain point in this case, is that in the hospital, right, you still had hours. For example, we discussed an example where there were 2 hours, but still 2 hours are hours. But in this case, right, you just have milliseconds. The customer is standing at the checkout, so you need extreme accuracy and at a very high speed. Because if you're late, let's say if a transaction happens and if you predict it 10 minutes later, in most cases, then not it won't help. Once the fraudulent transaction has taken place, it has taken place. So this is a very hard engineering problem to solve. Now we look at the case study which was conducted around this. This case study was conducted by Stripe, which is a large global payments technology company, right? So here is the key idea, and it is a genuinely elegant one. We stop looking at each transaction on its own. Instead, we model the whole system as a graph. Users, card, devices, etc., all of them become nodes, and transactions become the edges connecting them. So this was the theory built by Stripe, and then they built a system around it. Now, if we run a graph neural network over this structure, and suddenly we can see things a single transaction model is blind to. For example, let's take an example: 50 accounts that look independent but are secretly all using one device. So that is a fraud ring, and it only shows up when you look at the connections. If you keep looking at individual nodes, this won't ever show up. So in production, right, teams do this in two stages to stay fast. The first one is a cheap, quick model, which is often used as a gradient boosted tree. And it clears the obvious 90+%, and the heavy graph model only studies the doubtful few in the middle. And at the frontier, Stripe has built what they call a payments foundation model. Same idea as a large language model LLM, but instead of learning language, it learns the language of payments from tens of billions of transactions and turns every transaction into a dense embedding. Now, if we look at the result of how this system helped in this case was that if you look at the numbers, right, the numbers are very striking. Just by feeding sequences of these transaction embeddings into a model, Stripe reported the detection of card testing attacks where fraudsters probe, stolen cards numbers, etc., jumped from 59% to 97%. Now, that is a huge jump in prediction of fraudulent transactions almost overnight. And it did raise some false alarms, but they were very less. On the engineering side, right, eBay's graph system cut its worst case response time, what we call tail latency, by over 75% while staying under the real time payment deadline. But let me be honest about the hard parts in this case, right? Because that's where most of the research lives in the future. Fraud patterns keep drifting from time to time. So a model you train and forget will quietly keep rotting. And a regulator will not let you decline a customer's card and simply say the AI said so. You need a human readable reason on why the prediction was made. Because just assume you are trying to make a 2 lakh urgent transaction and your bank or your credit card keeps declining, saying that they suspect a fraud. And if you're not able to make that transaction after 4 or 5 attempts, you'll just pick up your phone, call the bank helpline, and ask them what is going on. Why do you keep rejecting my transaction? So, which is why what happens is teams add explainability tools like SHAP. So SHAP is what? It basically once the transaction is marked as fraudulent, SHAP basically adds an explanation around it, like why it was marked that way. And then later on, if it is found out that the transaction was not fraudulent, that constant feedback loop, right, we discussed in a second mental model, it goes back to the system as new data that you earlier predicted it as a fraudulent transaction, but it didn't turn out to be. That feeds the model again so that the accuracy goes on improving. Now, if we see where does this fraud sit on the curve, right? This is the most autonomous of our 4 cases. The system blocks a transaction by itself in real time and with no human in that split second loop, because if it flags it to the human, right, and a human were to review it, by the time the transaction would already be done. So we can't in this case, like in the hospital case, right, we had time to bring in a human because much more was at stake. But here, there is absolutely no time. Even if there are millions at stake in a fraudulent transaction case, we simply can't afford the time to bring in a human and allow him to review. So this, if we look at it, right, this is the stage 4 moving into 5. It is not fully into the autonomous stage, but it is slowly moving there. Now we move over to our third case study for the day. This is for smart cities, right? And we will be using urban traffic as our example because everyone in this room understands it, right? If you have driven on the Delhi to Noida stretch at 6 in the evening, you are already aware of this problem. Congestion costs us time. It costs fuel, clean air, etc., etc., etc. Now, here is what has changed. Modern cities are getting instrumented with thousands of IoT sensors at junctions and along the main corridors. And all of them keep producing a continuous stream of data that has both a where and a when to it. Now, this is the most important part, right? The where and when is associated to the data in this case. So the opportunity is to stop reacting to a jam after it has formed and instead predict and prevent it. Same reference architecture as before, but if you notice, right, the data is a completely different shape now. It is spatial and it is a time series data, right? So it has a geolocation and a timing attached to it. So now let's deep dive into the case study, what it was. So I picked this up from one of the Springer's magazines. So let us trace the data, right? It starts at roadside IoT sensors. And a lot of the first pass processing happens right there or in a nearby fog node because you can't afford to send every byte to a central server and wait because latency, of course, matters. So in this case, right, if you plug in cameras, etc., at every junction, for example, in say Agra or Delhi, there will be a lot of data. And if you keep sending all of it to your central server, that will be huge amount of data that you're sending to the central server, and which will bring in a lot of latency in the case. And we simply can't afford that. So the first bit of processing has to happen right there at the source, or let's say at nearby circles. For example, five IoT devices across one street, and they are sending to a small fog center, and where the data is getting pre-processed, and then that clean data flows up to the central platform, and that basically stitches the whole city together. And increasingly, vehicle and infrastructure talk to each other directly once all that data maps in, like what people call V2I and V2V, which is basically vehicle to infrastructure and vehicle to vehicle. Now, this model becomes interesting because traffic is two problems at once. It is spatial. One jammed junction will likely spill into the next, right? For example, if there is a traffic jam happening at Subhas Chowk right now, it will eventually move on to Rajiv Chowk in some time. And it is temporal as well. Like it keeps on evolving minute by minute. So it's not that the data just sits there and after 10 minutes or 30 minutes or so, we can analyze the same data for the same timestamp. After 30 minutes, the data may have changed widely. So researchers stack two kinds of networks, right, to prepare models which are capable of handling such data. First one is a convolutional neural network, which is great at spatial patterns, and an LSTM or a GRU, which is basically a long short-term memory or a gated recurrent unit network, which is built for time sequences. Now, honestly speaking, I don't understand how these models were built fully in depth, but if we sort of know which model to use for which type of data, I think that is more than sufficient in today's scenario, right? So if we put them together, we get a model that understands both where and when part, which is important in this case. And the action has two levers: change the signal timings and reroute vehicles before the queue builds up. So this was implemented in London, and if we look at the numbers, right, on outcomes, London's adaptive signal system, which was called the Scoot, right, was rolled out across 600 junctions, and it cut vehicle delays by around 13%, along with real drops in carbon. A similar study was also performed in Barcelona, right? If you look at the second box, the darker blue. Barcelona smart traffic system is credited with around a 21% cut in congestion and up to 30% faster travel. Now, if this may look small, but if you try to comprehend it, right, these are city scale results and not for a single junction. But smart cities carry their own hard questions. And if we were to discuss them, right, there can be a lot of hard questions in such cases. And that's why it did not go global. Like, who do you optimize the traffic for? The ambulance, bus, or the private car? How do you protect a citizen's privacy when there are sensors and cameras everywhere? And who pays for all this infrastructure? So these are not technical questions, these are mostly governance questions, right? And they still remain unsolved, with personal opinions of some people on one side while personal opinions of other people on the other side. But from a technical point of view, right, we are capable of building such a system, and it has been tested in the past across more cities. I picked up these two examples of London and Barcelona, but while reading this study, I saw that there were a bit of other cities also listed wherein this was implemented as a pilot. So now if we see where this is sitting on the curve, right, the mental model which we discussed in the second slide, this sits in the predictive stage going on into the prescriptive stage, right? The adaptive signals are the start of a closed loop, but a human city operator is still very much in charge because like we discussed, right, who do you optimize the traffic for? It may be the case that there is less traffic, but ambulance is coming that way. But on the other way, there is more traffic, but with no ambulance. And the system would just flag that it should allow pass to the more traffic prone area. But a human operator can take that call that if an ambulance is coming, others can wait for slightly longer and let that ambulance pass first. So it still needs a human operator in the loop. Moving over to the next case study for the day, right? This is across the retail industry and specifically customer intelligence and personalization. So the problem here is almost a paradox, right? An online store, for example, Blinkit or Zepto, which we all use on a daily basis now, right? It has a near infinite shelf, millions of products, but the customer has very finite attention. So if I were to, for example, go and buy some milk right now, I'm not going to spend more than 2 to 3 minutes, 4 minutes on my Blinkit app. So regardless of whether it has millions of products to show me, I'm only interested in a very finite attention period of time, right? Until I find my milk, and the faster it gives me that, the better it is, right? And on top of that, a small screen, right? So most of this thing we do on our phone. So we at a time we are just looking at 5 to 10 products on the screen. So the bottleneck here is not the stock. It is mostly discovery that is helping the right customer find the right thing at the right moment. For a data person, this is heaven because every single action the customer takes, right? Every click, every search, every item I'm clicking on my Blinkit screen, right? I'm viewing, for example, an item for 4 seconds. I'm not moving to other items. Or for example, for one item, I'm reading the description, I'm reading the ingredients, right? All of that is data signal, right? And it is going into the back end to Blinkit on which they build their models. So the challenge here is turning that fire hose of behavior into something that feels genuinely helpful. So it should not feel like you are being watched. For example, you have heard, you must have felt that as well, right? If you go and search something on your Blinkit or on your Instagram, if you search for let's say clothes, linen clothes, and you open your Flipkart and you start seeing linen clothes suggestion, you start feeling that you are being watched. So the model also should take care of not overreaching it, because the moment a person starts feeling that they are being watched, they start building up barriers and boundaries. So it is really important in this case to basically provide smart suggestions and not overdo it, which is the main challenge in this case. Now, if we see, right, let's move over to the next slide for us. So architecture and model. So architecturally, the first job is to stop having 10 different systems that each know a fragment of the customers. Because if we are running into this type of systems, the exact problem we'll run into is overreaching. And retailers pull everything into what is called a customer data platform, which unifies the browsing behavior and the purchase history and the basic demographics into one single profile per customer. And on top of that, we can place a recommendations model. There are a lot of recommendation models in the market, which companies are using. Uh, if we take a classic one for this example, it is collaborative filtering, which is just the people like you also bought this idea expressed mathematically. For example, if I'm buying milk from Blinkit, if 10 other people who also brought milk brought bread along with it, it will say that this is collaborative filtering, that people who bought milk also bought bread. So it will keep suggesting me bread when I'm searching for milk. And increasingly, there are deep learning recommenders that pick up far subtler patterns as well in such cases, including the sequence in which you do things. For example, the most advanced setup processes signals in real time. So the page literally rearranges for you as you browse. So if you are searching for something and you added it to cart, based on that, your other recommendations should change. For example, I was looking for milk, but I did not add it to my cart. So most probably I'll not buy the bread with it. Or for example, if I was looking for bread, but I did not add it to cart, I may not go for the butter along with it. But if I added bread to my cart, then I'm looking for food items. It will start showing up butter at the top. So the page is literally rearranging as I browse. And let's say I added butter to the cart. Then it will start giving me more suggestions. But if I remove one product from the cart, that screen, the suggestion screen must change live. And in some cases, if we see, right, the pricing also adjusts based on that. For example, you must have observed that if I go to one of the websites, for example, the Soul Store clothing brand, and I search for linen shirts, I keep looking for linen shirts for half an hour, but I don't buy it. After some time, I'll see the pricing has adjusted for me. It will send me a pop-up that this offer is specific only for you, rupees 100 off or 200 off. So what it did is it studied what all I viewed in the last 30 minutes or so. And I tried adding some coupons to bring the cost down, but then I did not buy it. So it is assuming that if the cost was just a little bit more down, I would have bought it. And it gives me that suggestion. And the interesting part is that suggestion also it will study. For example, if it gave me 100 rupee coupon discount and I bought that shirt, it will start showing that suggestion to other people as well. But even after that, if I don't buy that shirt, and across a large number, for example, if it gives that suggestion discount to 1,000 people, and only 5 out of them use that coupon to buy that shirt, it will probably evaluate that this coupon is not helping its use case, and it needs to change. So basically, the action is everything you see in this case, right? The recommendations, offers, order of the search results, etc., etc. So let's look at the business impact this has made for some real tech giants. We will take example of Amazon, Netflix, and McKinsey in this case, right? Business impact in this case is enormous, and it is very well documented as well. If we look at the studies, they link roughly 35% of Amazon sales to its recommendation engine. Uh, but Netflix one is my favorite. What Netflix says is about 80% of what people actually watch comes from recommendations and not search. For example, if you open Netflix and a movie pops up on the screen, you just click on it. So it studied that if I search a movie in the search bar, versus I click on what is showing up on the screen, the difference is huge. 80% of people are actually watching what is popping up on the screen. Same goes for YouTube as well, right? The videos which pop up on your screen, you watch them more often, apart from searching, which you do less often. And Netflix has publicly said that the whole personalization system saves them $1 billion a year, just in reduced cancellations. And across the industry, if we look at the third example, right, McKinsey estimates AI personalization gives a 10 to 15% revenue lift. So where does all of this sit on the curve, the mental model which we discussed previously? Retail is solidly predictive going into the prescriptive loop, and it runs in real time, and it constantly self-tunes through that feedback loop we drew. And every recommendation you accept or ignore, right, is training the next one, like we discussed in the previous example. But this is interesting because this is probably the most mature flywheel of all the four cases, because the loop is so tight and the cost of a wrong guess is so low in this case, right? If Netflix suggests me a movie which I don't want to watch, I'll just scroll past it. So there's no human requirement involved in this case. For example, if the model predicts that if I'm watching this movie, these other three movies should be suggested to me, it doesn't need a human to read and approve those, like in the medical case, right? Or in the fraud cases, it may have helped to have a human review, but only because we are low on time. Despite the risk is high, but we are low on time. That's why we can't afford a human into the picture. But in this case, a human is not required at all because the cost of a wrong guess is extremely, extremely low. So the model can keep learning it from itself very slowly, and there's no harm in it. Now, if we sorry, yeah. Let's look at all the four side by side. So this is just a quick summarizer of what we have sort of already discussed, right? Let us put all the four side by side. This slide is sort of important. Now, if we look at across the columns, the data sources could not be more different, which is the first one in medical cases in an EHR stream, electronic health record stream, which we discussed. And in the fraudulent detection, it is a payment graph. In the third case, it is road sensors. And in the fourth case, right, it's click streams. So all of these data sources differ vastly from each other. The models also differ from each other by a huge margin. But the shape, if you look at the shape of the data, right, and the flow, it is identical in all cases, like ingest, model, act, and feedback. And if you look at the last column, the human in the column loop, if you read it top to bottom, in healthcare and in healthcare industry, the human decides. In fraud, the machine decides on its own only because we can't afford a human. And between are the cities and retail, and that is not random. If you notice the patterns, right, the more dangerous a wrong decision is, the more we keep a human in the charge. Sepsis, human is getting to decide. A wrong movie recommendation, we let the machine run risk free. That single insight, matching the level of autonomy to the level of risk, is the most useful thing across all industries today. Moving over to the next slide, right? So where is this all heading, and how does it all connect back? We are moving from systems that recommend a decision to systems that safely carry it out. That is, from the fourth stage to the fifth stage, we are moving in the present scenario. And that is the whole idea today behind agentic AI. That is, software can plan a few steps ahead, take an action, look at what happened, and correct itself. For example, in the software industry, right? If you look at Claude today, Claude is able to code most of the things that human took long to code, but still we keep a human in the loop for accountability because tomorrow if the code submitted by Claude goes into a production system and breaks it, we can't just blame Claude and say that no human reviewed it and that's why that code went in. So we keep a human into the loop who is accountable to review the code provided by Claude. But if we look at it purely at Claude, right, what it is doing, it is if we give it a prompt, it is preparing something based on the our prompt. Now, if we give it feedback that the website or the code you created has these loopholes, it learns from them and it corrects itself. So if for example, if you can go back and try this out, give Claude any prompt for coding and just give it some boundaries. That is, once you finish your code, keep questioning the code, keep trying to break it. And if you are able to break your code, improve the code against those risks. So in the end, if you'll see, Claude will show you versions of code wherein the first version it prepared, then it tried to break the code, then it identified these are the glitches, then it improved it, then it again tried, then it again identified a few glitches, then it again tried to improve it. And after 10 or 20 cycles, it shows that this is the code I have prepared. Now, that may not be 100% fully fledged production ready code, and that is why a human will again review it. But from a system perspective, right, Claude is able to correct itself. So most of the softwares these days are in that last loop, which we were discussing, right? They take some actions, they take that feedback, and they keep continuously evolving. And every feedback is improving the system. For example, if Claude took 10 attempts to come to that code in the first try, right? It won't need 10 attempts in future. And that is what we have been seeing as well. When the first version of ChatGPT released, it was good. It was still good. But now if we compare it, it's way better because all of that feedback was taken and the system corrected itself. So useful way to think about it is the levels of autonomy views for self-driving cars, from basic driver assist all the way to full self-driving. So we are now building the exact same ladder for enterprise. Different industries are on different rungs as we saw across this presentation. I'll try and end it with a very strong opinion. The hard part of autonomy is no longer the intelligence. The models today are already very good. The hard part, if people will agree with me, is the guardrails, the human oversight, and a clear answer to one question. When the machine gets it wrong, who is accountable? And this is going to be the most important work of the next 5 to 6 years in the research as well as the enterprise industries. Moving over to my next slide, which will probably be the last one. These are key takeaways from my presentation. So let me leave you with 4 things which you can carry home. The first one is data only matters when it changes an action. Everything else is just a decoration. It's just a flashy board with some numbers or some graphs plotted across it. The second one is the same architecture pattern repeats across every industry. So if you master the pattern, right, you can walk into any domain and be useful. For example, we saw 4 examples of very different industries, but the logic, the pattern remained the same. Though the models were different, the data type was different, but the pattern was same. So if you try and master that pattern, that thought process, you can walk into any domain and you will prove yourself useful. The third one is set your level of autonomy by your level of risk. Be bold where mistakes are cheap and be careful where lives or livelihoods are on the line. And the fourth one, the genuinely hard and interesting problem is that we are not concerned about building bigger models. Of course, that will continue, but we are more concerned about data quality, drifts, ethics, and trust, and that is the future, right? This data quality, like we discussed, right, was also discussed by the previous presenter. Data is everywhere. So how do we determine what is the best data? What is the best data quality for my system, and what happens if the system drifts left or right? And what are the guardrails, what are the ethics, and how much trust can we put in the system? So I think that will continue over the next 5 or 6 years, and let's see how it goes. Thank you, everyone. If you want to reach out to me later, you can reach out on my email ID, which is sparsh.pandey@mongodb.com. And if you have any questions right now, we can discuss. I'll stop sharing my screen.
Thank you, sir. Yes, we have a question in the chat box.
Which recommendation approach performs better in retail, contest-based filtering or collaborative filtering? Thank you, Tanushi, for the question. So right now, right, in retail, both of these are being used together because a content-based filtering is important, but collaborative filtering will never go away. Collaborative filtering is based on your patterns around your area, right? For example, if someone in the US or in England buys bread, they are more likely to buy butter along with it. So that is collaborative filtering. Those recommendations will be made to people in the US. But in India, if someone is buying bread, they are more likely to buy milk along with it. So region-based collaborative filtering will go on, but a content-based filtering will also go on. So the solution is basically to club all of these together and bring out the best. You can't just rely on one thing in enterprise. Any more questions across the slide deck, or any other questions related to career in AI or in cloud? I can help with those.
I think there are no. Yes, one more question.
Do you think AI agents will replace traditional software, or will they mainly work alongside it? Okay. So this is an interesting question, and this is the talk of the town most of these days, right? I've been hearing it everywhere. So let me be very direct. I won't try to sugarcoat it. So if the software developers are just calling APIs from here and there, like they're not writing high level code, or they are not designing the applications at an architectural level, they will be replaced by AI agents pretty soon, because writing API calls from here and there, AI does today without any flaws. It's completely flawless. But engineers, right? Software engineers who are writing architectural level codes, they won't go. Traditional software will obviously be replaced, but engineers who are designing the systems, they'll stay and they'll work alongside AI agents to help AI agents improve and uh, provide that human feedback which is necessary. Now, when you say traditional software, what do you mean? Do you mean like software platforms, or do you mean like human part of it? I answered, tried to answer both of them, but yeah, if you could just clarify. Sorry.
So I think there is no more questions, sir.
Okay. Yeah.
Okay, sir. Thank you so much for your insight and inspiring lecture. Your valuable knowledge and expertise have made this session truly enriching for all of us. Thank you for your time and valuable contribution, sir.
Oh, thank you, ma'am.
Thank you, sir. So participants, it's time for a lunch break, and we will be resuming this session from 2:30 onwards. Thank you.
I'm audible, ma'am. I'm audible. I'm audible.
Yes. आवाज आ रही है मेरी? ठीक है
Good afternoon, everyone. Welcome back to this exciting afternoon session. We now move to one of the most anticipated segment of the event, a fireside chat on AI and future of work. Artificial intelligence is transforming every industry from healthcare and finance to education and manufacturing. As students and future professionals, understanding how AI is shaping career is more important than ever. To help us navigate this fascinating topic, we are privileged to have with us Dr. Urvashi Rahul Saxena, a renewed academician, and Ms. Barkha Jain, a distinguished industrial expert. Before we begin our discussion, I would like to invite Dr. Prachi Chabra to introduce our distinguished expert. Over to you, ma'am.
It's my privilege to welcome you to our session, and we are honored to have you with us and looking forward for your valuable insight. Dr. Urvashi Rahul Saxena is an academic professional and a researcher with over 21 years of teaching experience. She is currently working as a university professor and an higher degree by research coordinator for masters by research students in School of IT and Engineering, Melbourne Institute of Technology, Melbourne, Australia. She completed her PhD in CSC from JP Institute of Information Technology, Noida, India. Her research span key areas such as cloud computing, access control, trust management, and the application of artificial intelligence in education. Dr. Saxena has published and presented numerous impactful research papers that contributes to the development of secure, scalable, and intelligent computing system. Her dedication to academic excellence and research-driven continues to inspire innovation and advancement in the digital learning era. Now we have with us Ms. Barkha Jain is a marketplace strategy and an AI-driven e-commerce professional with over 11 years of experience driving business growth and across global marketplaces, including Amazon and Google and direct-to-consumer channels. She possesses extensive expertise in marketplace strategy, category management, business planning, P&L management, digital transformation, and leveraging AI intelligence to enhance the operational efficiency and business decision-making. We welcome you both to our session. Over to you, Megha ma'am.
Thank you, Prachi ma'am, for a wonderful introduction. Now let's begin the question that is in everyone's mind. First question for you, Urvashi ma'am. I'm audible, ma'am?
Yes, you're audible.
Thank you. Ma'am, AI is automating data analysis, report generation, and decision support tasks. In your view, will AI eventually replace the traditional analyst role, or will it fundamentally redefine what analysts do? Over to you, ma'am.
Thank you so much for this wonderful question, and thank you so much for having me in this AI summit. Now, the question, will AI replace analysts? I would like to redefine the question itself, because AI will not replace analysts, but perhaps AI is asking what kind of analyst will survive in the AI era. Because if we talk about the inventions, calculators came, and new kind of dashboard creation came, but still the role of analyst or the role of programmers or the role of because of cloud computing, the dependency on IT system engineers did not, it did not deplete it. So organizations don't hire analysts only to analyze the data, but they think that you need to update yourself and upscale yourself. So there is a kind of requirement that we need an integration of both these two aspects. It's not about human oriented perspective or AI oriented perspective, it's a merger of both of them. Thank you.
Thank you, ma'am. Same question for Barkha. Over to you, Barkha.
First of all, thank you for having me in this summit. And I completely align with Dr. That will redefine the role of analyst, not replace them. Because obviously, being an analyst and a consultant myself, I've seen this practically. That in the market, it aims to automate the repetitive steps, not to take the place of the real person who is developing it. So I think right now most of the analysts spend most of their times in collecting data, updating them, validating data, clearing, preparing dashboards, and etc. And in the coming year, I've seen myself in my organizations that I mean when the AI has come into the picture, creating these reports, and it can do it very easily and very efficient way. But now the analytics are analyst reports, not just creating the dash. Analyst of the future will be more will be evolving as strategic advisor rather than just being a every innovation creates I would say a higher value work for the humans. Rather than just taking place, they will actually empower humans rather than just replacing humans. I think collaborating of both will be the future. Human empowered by AI. Thank you.
Thank you, Berkha. Next question to you for Urvishma. Ma'am, as organizations rapidly adopt AI-driven analytics and autonomous systems, students often ask what skill they should learn. What technical and non-technical should today student develop? Over to you, ma'am.
Thank you, Dr. Megha, for this question. And this is a very popular question amongst, if among students, where at whatever graduate level or postgraduate level we go, students normally ask questions that what kind of programming languages, what technologies we should learn. Now, we need to understand this very important perspective that technologies evolve over time, so we need to learn capabilities. We need to be capable so that whatever may come, whatever era we are in, we are able to adapt ourselves. So the primary aspect is to inculcate the property of continuous learning, and that is one of the perhaps the program outcomes also in our engineering graduates, that we should inculcate an aspect of continuous learning. Secondly, because having said that, we're talking about the AI fluency. So when we say that data analysts tend to retrieve the data from, if we talk about the retrieval augmented generation and large language models, so data retrieval is one thing, but AI will work only on the data which is provided to it. So you should be capable enough to identify the data which is given as an input, whether it is authentic or not. So for that, you need to have strong data foundations, maybe with respect to the data analytics and maybe with respect to the conceptual basic properties of data structures. Apart from that, there should be the data should be translated in such a manner that it tells the story behind, from where the base data has been come after processing and cleaning and classification. What is the or elimination of the null values, what is the output which is expected? Are we working on the data in that right domain? So the AI landscape is not only about that we want to learn some programming skills like Python, or we want to create the transcripts, but human in the loop interception, which we call as HITL, that human in the loop intervention is absolutely imperative to understand that whatever decisions are being made, you should be capable enough to identify that if a program is generating an output, is that output needed? Is that output in compliance with the sustainable development goal? Is that output needed by the society? So that can come only by understand or by being capable, not only by learning programming languages. Because yesterday there was Visual Basic. Today we are talking every kind of data analytics basics is Python. Tomorrow something else will come. We have R analytics tool. In networking, initially I used to work on Cisco Packet Tracer. Now I'm working on JNS3 automation tools. So every now and then these technological advancements will come and evolve. So we should be capable and in the process of lifelong learning and continuous learning to adapt ourselves to the upcoming needs of the industry. Thank you so much.
Well said, ma'am. Same question for
Audible, Megha?
Hoshika. Over to you.
Thank you.
Yeah, I think this question was primarily for the teachers, and I think the respective teachers are already here. Who am I to say anything in this? But still, from my, I would say, from my corporate experience, as far as I know, the future belongs to professionals who are not limited to the technical knowledge, but also have, expertise in business understanding and strong interpersonal skills. So I think being a student, if I could have, I need to give any suggestions to the young students, I would say that they should first build their strong foundation of learning. I know latest technologies are here, the perspective are changing, AI is a regular evolving thing, and few things every day something new is coming. But still it is very important to have your strong foundation, which comes from Python, SQL, data visualization, and practical experience with generative AI. uh, though however technical knowledge is alone is no longer enough, that is for sure. And I think that is what Dr. Oishi has already mentioned in her time. And I think the technological knowledge should be combined with critical thinking, and the interpersonal skills, communication, business acumen is more important right now. Organizations are looking for people who are actually who can bridge the gap between the technology and the business outcomes. The last I think advice that I can give to young people right now, that don't wait till you feel like an expert in AI. Just start experimenting, do experiments, learn from failures, and just stay adaptable. That's it. Thank you.
Very true. So next question for Urushima. Despite rapid advances in generative AI and agentic AI systems, where do you see human judgment, creativity, and critical thinking continue to play an indispensable role? Over to you, ma'am.
So, I don't see human intelligence and artificial intelligence as two separate entities. In fact, I see that they both are complementary strength to each other. Now, there are certain key areas where the role of human is absolutely indispensable. I mean, if we talk about the perspective of, as Barkha said, critical thinking, even a study in Stanford, I have reviewed that it mentioned that in the era of Gen AI, I mean, in today's generation, maximum students tend to complete their assignments by just copying the question and pasting onto Gen AI tools, whether it is ChatGPT or whether it is Gemini or Claude or whatever it is. So, analyzing a question and thinking about what perspective, why is this question being asked, that sort of judgment analysis is a must. So that is the empathy. I mean, artificial intelligence cannot sense the conditions which an individual is, so that leadership quality or that kind of understanding of human emotions or societal conditions, that is very much important. Apart from that, if we talk about the ethics in terms of are we taking care about the ethical responsibilities of development of a particular tool? What kind of contribution will a development, for instance, whenever we see that a robotic instrument is being created, what kind of impact that particular instrument will lay to the society? And so these kind of prominent areas with respect to the vision in mind, with respect to the long term vision, that our contributions should not hamper the existing systems, but perhaps they should this particular artificial intelligence should help human intelligence evolve, and always the basic decision making in order to counter check that whatever, for instance, if a patient's report, we cannot completely rely on a decision making system or a recommendation system for healthcare models, right? On artificial intelligence, because we need that human in the loop intervention to be sure that whatever decision has been taken, so we are sort of integrating these two intelligence models. That is my take on that.
Thank you, ma'am. Same for question for Barkha. Over to you.
Thank you.
I think every question has been already being very well explained by Dr. Rishi, and nothing is left for me to say in regards to that. But I think yes, as I said earlier as well, and ma'am has also acknowledged it in her period of time. But I would say creativity and critical thinking are the two things which AI is lacking, and will always lack, and there is a human judgment will always be needed. Because even myself being a part of being in the automation drive at Amazon, uh, I wrote a lot of BRDs, which were actually interpreting the business needs to the tech people. And while making those business requirement documents, I came to certain level that there are many steps in the BRD which I cannot explain it to them, and they are highly dependent on human judgments. So I can very well said that with the practical experience that I had while doing a job in a corporate and an organization at Amazon. Because AI is, I could say that AI is very well much developed in identifying patterns, creating data sets and everything, which is already been embedded in the system. But creativity is a unique human strength, and it comes when you challenges the assumptions, you generate new ideas, why the new startups are booming in the startup culture, because they are doing something, they are actually relevantly solving some real problems, right? Specifically, if I say that earlier we never had medicines at our disposals within 10 minutes. Now there are so many startups which are there, like Tata 1mg and Farmeasy, or different popular startups, I could say. They have built this setup, they have on the e-commerce platform, and now we just buy order the medicines, and we have the medicines within like 30 minutes at our disposal. So there are so many of the opportunities which are yet not had been tapped till now, and which can only be solved by human intervention. AI will not create its own platform and say, yes, now this is the burning problem in India, or this is the burning problem in this state, and now I will create it, and this will be the module, this will be the no. AI will not do that. AI will only can create patterns which are already known to them. It can increase in your efficiency, it can help you do your work easily and in an efficient manner, in an easy manner, in a timely manner, but it cannot generate new ideas. Similarly, like critical thinking, as she said, that human intervention, human loop is there. I myself created so many strategies for different brands, and there are many a times that, like technologically, we see that there are two options, and both are not very I would say not in a profitable manner, but both are actually causing the losses to the business. But now here comes the human intervention, that okay, now it's depending on the brand owners or the brands, that they have to choose which path is less uh, I mean which would create less damage to their wallets. So that's where the long term strategy and long term human intervention and critical thinking plays its part, that they will choose the path which will help them in the long term strategy consequences. So yes, I mean, creativity and critical thinking are the two main pillars which cannot be embedded in AI, and human intervention is very much needed. Thank you.
Well said, Dakha. So the last question for Urvashi ma'am. If you are if you were starting your career today in the age of AI, what would you be the learning roadmap and what advice would you give to students aspiring to build successful career in data science, AI and analytics? Over to you, ma'am.
Okay, thank you. Thank you so much. So today, every individual, I will say that every one of us is a student and will always be. So every individual, whether in India or worldwide, need to understand that no technology can replace, but we don't need to be afraid. We don't need to compete with any technology. You know, whatever individual perspectives or whatever individual qualifications we have, we need to extend and expand that in compliance with AI. That today also I can see that many of the students and many of the teachers and researchers also, they are upscaling themselves by different kind of certification courses or different kind of new technological advancement, so that we always talk about the roadmap, but we have to drive in that particular road to reach to a destination. So learning AI tools is not a destination that I've reached a destination. I know how to run this AI tool. Why? Because something else will come, and then I need to learn that. Then I need to be in pace with. In fact, we need to be in pace with our students, the upcoming generation, and the future of tomorrow. So we don't want them to face any kind of crisis, because talking about India as an economy, if I say that, the biggest advantage which we have is the talent pool. And this talent pool has immense capital to launch new and to become entrepreneurs. And talking about JSS University, we know that we have the step over there, which is the Center for Talent and Entrepreneurship. So we promote building ideas, thinking about new ideas. And as Barkha has already said, that startup is about, you have an idea, you bring into practice. How much capital investment is created out of that? That is a different thing. But having said that, artificial intelligence, when we started learning this, but the thing is that from automation, there is a shift from automation to decision making. So artificial intelligence is trying to avoid human intervention, but it will never be able to replace that fact, because that final decision of acceptance of a particular acceptance of a particular task, whether it should be what is the relevant judgment which is being made, or what is the impact that it will give, that has to be taken care by the programmers or the researchers in whatever domain we may be. So that is a little bit of my take on that. Thank you.
I truly agree with ma'am. Now, same question for Barkha. Over to you.
I think I stay true to my point that the foundational studies of having Python, SQL, data interpretation should be the must, and over top of that, learning new cloud computing, cloud module deployment, AWS, Google Clouds. You need to have this basic knowledge for sure before entering into the era of AI, because AI tools like Claude, where you can have all the coding itself, and make the UI, making the app, making the this website is very easy now. Even I can do it. I don't have that much of a technical expertise, but even I can do that now. So, but how who who told Claude to build such kind of programs, to create such line of items and enable that kind of apps? How the apps will be evolving via cloud? So I think the fundamental knowledge will remain at its place and its peak, but again, I would say in the upcoming era, beyond technical expertise, I would invest more time in communication. Storytelling, the art of storytelling is very much important. The stakeholder management, the understanding the business strategy. Companies are looking for the professionals who can translate complex AI capabilities into practical business solution. So now there is a fine line between the hardcore coders and the business analyst. So now the coding and everything is automated at the developer's end, but now the analyst, instead of creating reports and dashboards, they are investing more their time on generating the insights out of it. Like what is the impact of it, how can we take actions on it, what are the action items we need to work to to grow such thing, to grow any KPI if we have any. So my advice to students is just not simply know about the recent technologies and recent AI tools. Think of being someone who can solve meaningful problems using those AI tools. Don't chase the latest technology. Just try to think that how it can help you in survive in the realistic world with the newest what are the companies are looking forward to, how it can help. If you don't want to be a 9 to 5 job professional, if you want to be start your own thing, just always think that if I'm learning this, how it can impact real life problems that I am looking to solve in the real space, in the real environment, in the real life. So I think learning and smart learning, both are the things which the person should know, that what is going to impact their goal, aim, and what is the they shouldn't learn things which would there is no checklist that you should learn this. No, learn anything which is smart. Learning is the efficient way to to have success in whatever career you are opting for. So yeah, thanks.
Thank you, Barka. I'm sure the participant has gained valuable perspective on the future of AI and the evolving world of work. Now, we we now move on to the panel discussion session. Now, I invite Dr. Sukhen Singh to continue with the panel discussion. Over to you, sir.
कैमरा नहीं ऑन करना ना कैमरा कंटिन्यू विद कैमरा नॉट कैमरा hello am I audible?
Yes, you're audible, sir.
So, good afternoon, everyone. This is Dr. Sukhendra Singh, Associate Professor, IT Department, and moderator for this panel discussion. I hope you all enjoyed the insightful technical sessions and engaging fireside chat. We are now moved to one of the most anticipated segment of today's AI summit, that is the panel discussion. Artificial intelligence is no longer just a technological advancement; it is transforming the way we live, work, learn, and innovate. While technologies continue to evolve rapidly, understanding their real world impact and future directions require perspective from experienced leaders who are shaping this transformation. It is my privilege to moderate this today's panel discussion. We are honored to have with us two distinguished experts. Our first panelist is Dr. Urvashi Rahul Saxena. Dr. Saxena brings extensive experience in artificial intelligence, data intelligence, and technology leadership. Her work spans research, innovation, and practical deployment of AI solutions across diverse domains. We are delighted to have you with us, ma'am. Our second panelist is Ms. Barkha Jain. Ms. Jain is accomplished industry professional with rich experience in AI, data science, and digital transformation. Through her work with industry and emerging technologies, a warm welcome to you as well, ma'am. Thank you both for taking time to join us today for sharing your valuable insights with our students, researchers, and faculty members. Without further delay, let us begin our discussion. My first question is on AI trends. Urvashi ma'am, my question to you is for you. Since artificial intelligence is evolving at an extraordinary pace with innovations emerging almost every day. So, in your opinion, what are the most exciting developments in AI and data intelligence that organizations should pay attention to over next few years? Over to you, ma'am.
Thank you so much, Dr. Sukhen, for particular question. And the industry is moving towards from automating a particular system to taking autonomous decision. I have quoted this statement earlier also. And there are three popular development models which we should focus on. One is trustworthy AI. Trustworthy AI means we should not blindly rely on whatever decisions have been taken by the large language models or the small language models, but we should think that whether we need to accept and follow those decision making, what is the what are these trustworthy, because trust is quite subjective in nature. So we need to be concerned about the privacy and ethical aspects of it. Secondly, intelligent decision making. What are the input parameters, what are the if the dashboard we're talking about, what kind of scale or what kind of data has been taken into consideration. And nowadays it is a very popular term, agentic AI. Everyone is talking about building AI models, but what is the susceptibility? I mean, what is the reason? Because AI models are being thought process for that they should be capable enough to plan, reason, resonate with the problem definition, and in compliance with the executing multi-programming and multiprocessing, so that they're able to help humans, not to replace human. As an analyst, these development perspectives are something which everyone should inculcate in themselves, so that every individual is sustainable over the upcoming years, and we don't get afraid that okay, something will replace us, or it is going to be how the exciting developments are taking. So we should not be afraid, we should be in pace with it. That is what I feel. So future is not belong to those individuals or those business enterprises who are adopting AI, but who are adopting trustworthy AI and who are working with that. That is my take on that. Thank you.
Thank you, ma'am. Those were truly valuable insights into the future direction of AI and how organizations can prepare themselves for the next wave of innovation. Now, I would like to invite Ms. Barkha Jain to share her thought. Since students are naturally curious about preparing themselves for career in AI and data science, what is skills and technologies and areas of expertise would you recommend students and young professionals to focus on build successful career in AI and data science? Barkha,
I
ma'am.
think I think I've already answered this question, and there are very so many valuable teachers are here. Who am I to say anything in that? Because you are the builders of individual into a professional and professional into a business tycoon. So teachers play a like highly regarded role in an individual's life. But still, if I would have to add anything to the expertise, I would still again say that strong. I would say that try to build strong foundation, because today, even till today, the people who can create, uh, people who can. Uh, uh, Mr. Sukendra, can you please put yourself on
Yes,
mute?
ma'am.
Yeah. So I think the students should build a strong foundation in mathematics, statistics, Python, SQL, data interpretation, and generative AI. And uh, AI agents or cloud computing is itself very important till now, because AI is continuously evolving. And to evolve AI, there is a need to have strong, programming skills. organization are still looking for professionals who are still paying the higher packages and a higher still willing to take the talent who can help in developing the AI. Till now AI is in a stage that who can automate the workflows or eliminate the repetitive workflows, but it is still not developed yet to take place of humans, and who can take judgments which can have which can drive the business impacts. So I think students should have should focus on having a high strong foundational skills, but yes, I will still say don't wait until you become the expert in AI. Keep experimenting, keep something going, start building, experiment things, learn from your failures, and stay adaptable, because there are AI is evolving at an unprecedented pace, and it is very difficult to sometimes catch or be equally updated with that kind of pace. But at least you should be aware of what is the technology which is running, or which is like opted by the organizations. But at the same time, you should be a good you should improve your interpersonal skills, because storytelling, without storytelling or without good stakeholder management, you cannot go up in the ladder. That's what I can say as for my from my professional experience.
So thank you very much, ma'am. I am sure our students will find your guidance extremely practical and motivating as they prepare for their professional journey. Moving on to our next question to Rosi ma'am. Since AI is creating measurable impact across healthcare, education, finance, manufacturing, and many other sectors, could you share an example of how AI or data analytics is creating meaningful impact in your organization, industry, or area of work? Urvashi ma'am, this question is for you.
Okay, thank you so much. So, recently, in Melbourne Institute of Technology, we had a session. We had a project conference which was called as Impact, and that impact itself created a huge impact because my supervised project group, they worked on a project named as Cloud Invoke, and they worked on my entire research is on trustworthy cloud. So I integrated cloud with AI, and my students compared two AI models, one with Google Cloud and one with AWS Cloud. So now, normally we encounter situations where there is a hit and run case. So my students developed an agentic AI model in which, if a car is running at an extremely faster speed and you capture the image, but because the number plate is not readable because that particular car was running extremely faster, so they saved that image into AWS buckets and GCP buckets both, and then they simulated a program based on with text retrieval was being done from that image, and then the number plate got clear, and eventually the case can be closed and you're able to identify the number plate. So what I mean to say is that there was a motivation for this particular problem, that such kind of accidents or which can hamper the society, is artificial intelligence developing such kind of projects which can help or contribute in the societal impact. But I also agree with what Barkha has said. You have to be having the strong foundations. So we always introduce, even in JSS University and any popular university, we introduce those subjects as of the strong statistical foundations and strong foundations of data structures and algorithms, because it is very much important to create a concept that human intelligence is a must. So my students over here or in India, we always try them to challenge the system. If you have given a prompt in a certain manner, you will get small language model. It will generate output only based on the historical responses, which is fed into their model. What if we want to get something new? So constructive alignment with the scalability and that kind of foundational skills is very much important. So whatever technological advancements are going on, we should not forget that we have to be in pace with the base should be stronger. Like we always say that because the foundation of an individual is strong, he can reach anywhere in the world. So my recent experience was with one of my project groups, and I was really happy about it. So yes, thank you.
Thank you, ma'am. I believe the real world examples like these help bridge gap between academic learning and industrial applications, allowing students to appreciate how AI creates tangible value. So my next question is for Ms. Barkha Jain. Since India has emerged as one of the fastest growing digital economies, and is expected to play a defining role in the future. So as we move forward, increasingly intelligent and autonomous systems, what opportunities do you see for India in becoming a global leader in AI-driven innovation? Barkha, this question is for you.
Yeah, thank you for the question. Um, I think um, India is uniquely positioned to become the global AI powerhouse because we have one of the largest talent pools in engineering and technology and a thriving startup culture, startup ecosystem, which has been backed by government organizations and increasing digital adoption. I would say this is the very big part that I've seen myself. I've been working with the German organization, and when I was working with the Germans, I myself has experienced that how technologically backward is Germany is. Over here we are actually paying the fruit vendors by just by the UPIs, and they are taking the payments, even though now even now the beggars have their QR codes. But in Germany, if you go to food vendors or anywhere, you still have to pay by cash. Their logistic problems are still like back in 2000s where we were in India. So they don't have that much of developed setup till now, although Germany used to be the manufacturing tycoon, or you can say power all over the world. We used to even till now, I think the hardware manufacturing, we find that okay, this is the German machine, this would be the best one, right? We have that kind of mentality, but now the scenario has completely changed. India is going way beyond in adopting the technologies. Tier 2, tier 3 cities, I've seen myself what is their contribution in the revenue in the business perspective. I've myself created so many strategies for the brand to tap that untapped opportunity in tier 2 and tier 3. And this is why this is happening, because in India there is a whole lot of scope of developing new things, and again there is a lot more scope of adapting it, because people over here are not reluctant to it. Earlier people think twice while buying something online. Oh, will it come? Oh, will it be returned? Will be getting the refund or not? But now it's very common thing. Even rickshawalas or any maid that I have in house, they prefer buying online during the prime days. So I think the whole scenario has been completely changed, and I think the next wave of opportunity of building AI solution will come in sectors like farming, manufacturing, and agriculture, healthcare. Healthcare is a booming sector, will always be a booming sector, and logistics, public services. So beyond being a consumer of AI technology, I would say India has a opportunity to become a creator of world class AI solutions or products. So I think by investing in research and high quality data sets, responsible AI frameworks, India can play a leading role in becoming or world leader of AI products and shaping the future of AI. Thank you.
Thank you, ma'am. Your insights beautifully highlight the tremendous opportunities that lie ahead of our country for the next generation of innovations. Uh, Before we conclude, I would like to invite both the esteemed panelists to share one final thought. What advice would you like to give our students, researchers, and aspiring professionals who wish to contribute to the future of AI and data intelligence? Dr. Rosie Rahul Saxena, may we begin with you?
Okay, thank you. So the biggest advice which I would like to give not only to the students and to all of you, but to myself also, is that we should always be inquisitive. We should never be afraid to ask questions, because any kind of curiosity that why this is happening, looking like that, or why a system is giving only this amount of result, that will open the doors for better amount of research. And there is a very wrong preconceived notion about research, that someone who is doing a PhD is only doing research. Even if you are, gathering an information in a book from a library, nowadays students hardly do that, but even if you're searching online content of a particular topic, that is also a research, because it is all about gathering the information and learning something new. So building strong foundations, don't rely specifically that one of my friends or one of my acquaintances have told me that I need to learn these AI tools, so I will learn them. No. Now should be in compliance with the 17 Sustainable Development Goals, because any information technology industry, any big IT industry, they should create projects, or they should have their clients in pace with respect to the 17 SDG goals, and we're talking about energy conservation. So we should think about that much responsible use of AI, like green computing. Like I'm working on cloud computing, so I'm now quantum computing is one of the upcoming research areas. So we should think about including AI in such topics which can contribute our society, which can help in global issues like global warming and economical perspectives, and help in the GDP, gross development, gross profit for and development revenue of a particular country. So the GDP should increase and the revenue should increase, but the intent of any kind of research is most important. So AI should help and contribute for the lasting impact, that this is the objective. The objective should be absolutely positive. This is a little bit of advice which I can give to everyone, including myself. Thank you.
Thank you, ma'am. Ms. Barkha Jain, your thoughts, please.
I think based on my experience and the experience that I had being a student myself from college, then converting into a software professional, after that being a seasoned co-founder before transitioning back to corporates. I could clearly say two things for students which are falling in two categories or two buckets from my perspective. That if you are a good coder, if you are a good at developing something, focus on your fundamentals, focus on developing something which is actually meaningful to the real life problems. But even if you are not good at coding, don't dishearten yourself, because AI is here. People who are sitting beside you who is a very good coder could create a dashboard or could create a chat prompt who like Claude, who can with which you can take help of creating a good real time solution which you can develop with your limited skills. You can learn Claude, it's very easy. But I think before using and taking the help of AI, you should go in the market, you should go in the for the real time experience, gather experience, do research. Even if you are starting some business yourself or creating a startup in any field, try to gather as much experience you can, and then try to translate your experience via AI tools for solving the real problems. Don't constrain yourself that, okay, I'm not a coder, I don't know how to do this. How will I develop an app? How can I, build a real time solution? Don't hold yourself. Just be opportunistic and be consistent. That's it. Thank you.
Thank you, Dr. Urvasi Rahul Saxena and Ms. Barkha Jain, for sharing your experiences, perspectives, and valuable advice with all of us. Today's discussion has highlighted not only the immense potential of artificial intelligence, but also the importance of continuous learning, responsible innovation, and interdisciplinary collaboration. I hope everyone attending today's summit leaves with new ideas, fresh inspiration, and greater confidence to participate in the exciting future of AI. On on behalf of the Department of Information Technology, JSS Academy of Technical Education, Noida, I sincerely thank our distinguished panelists for their valuable time and thoughtful contribution. I also extend my gratitude to all the participants for joining us and making this AI Summit a success. Thank you, everyone. And now I request Dr. Prachi Sabra to proceed further.
Thank you, sir. Good afternoon, everyone. It's my privilege to propose the vote of thanks at the successful conclusion of the one-day online summit on the Data Intelligence NEXUS 2026 from Analytics to Autonomous Decision Making, organized by the Department of Information Technology, JSS University, Noida, under the divine blessings of His Holiness Jagat Guru Shri Shivratri Deshkendraya Mahaswamiji. I express my sincere gratitude to our Honorable Vice Chancellor, Dr. H.R. Mahadeva Swami Sir, for his visionary leadership and constant encouragement in promoting academic excellence and meaningful industry collaboration. I extend my heartfelt thanks to Dr. Mamta T.G. Ma'am, Registrar, Dr. B. Manoj Sir, Dean Academics, and Mr. N.S. Manoj Sir, Finance Officer, for their continuous guidance and encouragement in making this summit a grand success. My special appreciation goes to our summit chairperson, Professor Jagdish R.S., and our convener, Professor Lapkush Sharma Sir, for their valuable guidance, thoughtful planning, and continuous support, which played a vital role in the successful organization of this summit. I would also like to extend my sincere gratitude to all our distinguished speakers for sharing their valuable knowledge, rich experience, and insightful perspectives. My heartfelt thanks also goes to all the head of the departments, faculty members, students, industry experts, and participants for their participation, engaging discussions, and valuable interaction throughout the session. A special note of appreciation goes to our organizing team, the technical support team, faculty coordinators, and students volunteers whose dedication and teamwork ensured the smooth and the successful conduction of this event. Finally, I thank each one of you for being a part of this summit. Thank you once again. Dear all, kindly fill the feedback which has been shared in the chat box.
I would sincerely like to thank everyone. First of all, I would like to thank the visionary leadership of Dr. H.R. Mahadeva Swami, Vice Chancellor, JSS University, Noida. Secondly, I'd like to extend my heartiest gratitude to Professor Dr. Lavkush Sharma, HOD Information Technology Department, and the convener of the summit for inviting me the opportunity. And a special thanks to the entire organizing committee
Thank you, ma'am.
Thank you, Dr. Urvashi ma'am. We were also honored to have you. And by this, we conclude our session. Thank you once again. Thank you.
Thank you all for having me in this AI Summit.
Thank you, everyone. Bye-bye.
Bye.
Thank you, Urvashi ma'am and Barka.
Now you can.
Thank
Thank you.
you. Thank you for joining.
Okay, thank you. Thank you.